Before starting the event, there is one small request to everyone. Please keep your mic and video off until invited in order to have an uninterrupted and smooth e-conference. Thank you. Hello everyone present here. I am Cadet Varun Rakesh Patel of BTech third year, along with Puneet Keshri BTech third year and Cadet Vaishnavi Harish of BTech second year. It would be a great exaltation for us to host this event.
Honorable Chief Guest, Vice Chancellor IMU, Director IMU Chennai Campus, respected faculties, and everyone attending this event, good morning. I, Cadet Vaishnavi Harish, BTech Marine Engineering second year, on behalf of myself and on behalf of School of Marine Engineering and Technology, IMU Chennai Campus, feel privileged to extend my warm welcome to all of you to this two-day national level e-conference on energy, environment and sustainable shipping organized by the School of Marine Engineering and Technology, IME Chennai campus. George Herbert once said, prayer should be the key of the day and the lock of the night. We would therefore start this event with a prayer. I request all respected dignitaries and professors to rise for the invocation. Thank you all. I request all dignitaries to kindly take their seat. Light is a symbol of brightness and prosperity. To make this event a blessed one, I invite our Honorable Director, IMU Chennai campus, and other dignitaries on the dais to kindle the lamp of knowledge and wisdom. Thank you all. I request all dignitaries to kindly take their seat. I invite our learned HOD, School of Marine Engineering and Technology, IME Chennai campus, and the convener of this e-conference, Dr. K. Sivasamy sir, to come onto the dais and endow us with an introductory address.
Morning all. I extend a warm welcome to our distinguished Chief Guest Sri Uday Purohitji, President, Institute of Marine Engineers, India, Honorable Vice Chancellor Ma'am, beloved Director, respected delegates, session chairs, participants, faculty members, and my dear cadets to this two-day National E-Conference on Energy, Environment, and Sustainable Shipping. Knowledge is power, and investment in knowledge pays the best interest. Moreover, technology is driven by ideas. For the growth of technology to serve the society, useful ideas should be appropriately connected. We believe that conference is one such forum to serve the purpose. We, with the able guidance of our beloved director, decided to organize a national level conference during April 2020 in association with Institute of Marine Engineers India. In light of coronavirus COVID-19 pandemic and as per government directives, we were supposed to postpone the conference. People may physically quarantine, but still they can be linked by electronic means. The effort of conducting this national level conference through electronic mode is realized with the support of VC Madam and Director, and certainly with
Please wait for some. Due to unexpected power cut, we will be having
Presentation how can
please wait for some.
ನೀವೇ ಹಾಕಿರೋದು ಅದಕ್ಕೆ
I'm sorry to interrupt. I can hear a loud screeching noise. Is that only me, or are the others also experiencing it?
Yes, sir. I therefore request everyone else to please mute the mic, sir. Please.
No, the audio has gone off. Varun, please check up with the persons who are actually presenting or speaking. Nothing is heard.
Yes, ma'am. Actually, there is one power cut, unexpected power cut, ma'am. Please wait for a minute.
Okay.
small break. The effort of conducting this national level conference through electronic mode is realized with the support of VC Madam and Director, and certainly with the involvement of our team members along with our energetic cadets. We are grateful to the Institute of Marine Engineers India for their patronage and our sponsor, National Institute of Ocean Technology. We received more requests for this conference across the country, and our scrutiny team has selected 27 relevant papers for presentation. Like any other industry, big industry also innovates regularly and adopts and sustainable shipping report moving in the current trending bird in marine sector. The theme of the conference was decided based on the most common safe, secure, and efficient shipping on clean water and the World Maritime Theme for sustainable shipping for a sustainable planet. Marine engineering has sufficient scope for involving other engineering disciplines. Accordingly, we have 4 sessions covering following items: marine energy, environment and management, electrical, electronics, control and automation, mechanical and materials, and sustainable shipping. The entire SM meeting guarantees happy voyage all the way. Again, I welcome all of you. Thank you.
Thank you, sir. I now request our esteemed director, IME Chennai campus, Dr. Raju Balaji sir, to deliver the welcome address.
Sir, we are not able to hear. Please. Yes, sir.
Dr. Balaji, you are not audible, sir. You are not audible, sir.
Director, sir. Yes. Please check the mic.
Am I audible now?
Yes, sir, audible. Yes, sir, audible.
Yes, audible.
I go again.
If you have to speak louder, I think the volume has to be increased.
President, Marine Engineers India,
Dr. Balaji.
Vice Chancellor,
Dr. Balaji, sir. Sir, not audible. It's very faint. You need to come closer to the mic, please.
Yes. It's recording, but SARS is not capturing because in between he is presenting. Ask him to present only during the session.
okay. Hear me now? Right?
Dr. Balaji, only very, very faintly. You are at a distance. It's
Now? Is it better?
slightly better, but not good enough. Sorry. Since it's an e-conference and people around the country are going to listen to you, maybe we take a couple of minutes and get it right.
Okay. Okay, sir.
How about now? Is it audible? Uday, how is it sounding now?
Under pressure, I will say yes, but if I were to tell you honestly, it is still not a clear sound, Raju.
Okay, I hope that it gets better. I think
Okay.
we'll get going.
Let's move on.
Okay.
Sorry.
Okay, that's technology tantrums. Apologies for that. Shri Uday Purohit, President, Institute of Marine Engineers, India. Honorable Vice Chancellor, Dr. Malini Shankar. Participants, colleagues, dear students, a very good morning to you all. On behalf of Indian Maritime University, I welcome you all to this e-conference on energy, environment and sustainable shipping. While energy and environment are co-equal, sustainability is rather a concern. Steve Jobs said, I want to put a ding in the universe. The mankind has done more than that to the environment while exploiting the energy resources, making sustainability a concern. To make amends, decarbonization targets have to be pursued. The world energy demand is expected to peak in 2030, that is, in a decade from now, and expected to reduce as we move towards 2050. Transport sector, where shipping is a part of, will be the third largest consumer taking a 20% of the generated energy. At this midpoint of the century, the economic growth would be around 130% from 2016 levels, and the population expected to be at 9.2 billion. With the expected transition into other resources, solar, wind, there will still be dependence on oils and natural gases. In such a scenario, why would the energy demand decline, though the economic growth would register such massive gains? The major reason would be energy efficiency, tuned with data and digitalization. The energy efficiency measures we are contemplating today will have a telling effect on the environment and the sustainability of our conventional and emerging technologies when we reach the midpoint of the century in 2050. With such contemplations, conferences and forums like these will help in sharing new thoughts and bringing forth better awareness. Malcolm Forbes, the founder of Forbes magazine, said, "Education's purpose is to replace an empty mind with an open one." I wish this conference has valuable inputs to stimulate your open minds. And I compliment the Marine Engineering School of Chennai campus in organizing this forum. I welcome you all once more. Thank you.
Thank you, sir. I invite Honorable Vice Chancellor, IMU, Dr. Malini V. Shankar Madam, to deliver the presidential address and initiate the conference inauguration.
Uday Purohit. Shri Uday Purohit, participants, IMU fraternity, and dear students, a good morning to you all. It gives me great pleasure to address you all in this e-conference on energy, environment, and sustainable shipping. Shipping is part of the transport sector, which is one of the major energy consumers. This naturally makes it a part polluter too. Being a crucial trade mover vector, it's imperative that the energy demands and energy management of ships must work on sustainable models. In the past decade, there have been many serious efforts to improve the energy efficiency as also bring down the harmful emissions to environment. Driven by decarbonization philosophy and targets, ships are adopting to energy-saving measures operationally, as also the new ship builds are going green. Slow steaming, trim optimization, voyage planning and optimization, remote surveying, predictive maintenance based on condition monitoring data, etc., are all happening on board conventional ocean-going vessels. New builds with smoother hull forms, machineries with green technology, etc., are emerging. The most recent initiative by the IMO is on the use of low sulfur fuels apart from compliance requirements on data being monitored to achieve and record targets. There's also been active research on alternate fuels such as LNG, ammonia, hydrogen, biodiesels, etc. New thinking on energy management has gained traction with the developments in data analytical tools, artificial intelligence, and machine learning. In a sense, the future energy management will be driven by digital technologies. There is an urgent need to capture and comprehend the knowledge which is building up rapidly in these areas. National conferences such as these bring about the sharing of select knowledge. In the broader spectrum, the Indian Maritime University has a greater responsibility and role for taking the knowledge to all. I congratulate the School of Marine Engineering and Technology to make this happen. Matthew Arnold, the poet, said, "The free thinking of one age is the common sense of the next." We are in such times when new ideas are being born and tried out. I hope the Z-Conference will bring many free thinking ideas for you to enrich your knowledge. I am indeed happy to inaugurate this conference and wish my best for its success. Thank you.
Thank you, ma'am.
Thank you, ma'am, for your enlightening words. Now, the most awaited moment of the day has come. We have our keynote address, but before calling our keynote speaker, I am profusely elated to take an opportunity to introduce our keynote speaker of the day, Sri Uday Purohit. Sri Uday Purohit is an alumni of DMIT Kolkata. Mr. Purohit completed his certificate of competency, both class 1 and class 2, from UK. He is a chartered engineer. After a seafaring career spanning over 15 years, Mr. Purohit founded his company, Neptune's Power Plant Service Private Limited. So, with this, I would like to invite Sri Uday Purohit sir to say some few words. Sir, please.
Dr. Malini Shankar, Vice Chancellor IMU, Director IMU Campus Chennai, Dr. Raju Balaji, some old friends that I can see on the screen, Pawan Kapoor, Captain Bharadwaj, Captain Ramdas, Dr. Shiva, and others, ladies and gentlemen, very good morning to you. This is truly a momentous day when the School of Marine Engineering, IMU Chennai campus, has organized a conference, an e-conference on a national scale. Perhaps it is no coincidence that this seminar has coincided with Dr. Malini Shankar taking being at the helm of the IMU. Every time we have a marine accident, and we've seen quite a few in the past few months, there is a call to look at shipping as being sustainable or not. And sustainable shipping is so entwined with the environment. The favorite whipping boy of environmentalists is fossil fuels. And every time we talk of sustainable shipping, the question of the usage of fossil fuels, alternate energy sources comes into play. So I'm going to now link this to the rate at which technology is progressing in the 21st century. Ray Kurzweil, the director at Google, says that we are entering into an age of acceleration and that we are going to see more change in this century than we've ever seen in the past 60,000 years of recorded or understood human history. That by itself is both exciting and frightening. The rate at which technology is developing today is outpacing humanity's or mankind's ability to grasp it. That means most of the time, most of the people are not going to understand the technological changes that are brewing, so to say, around the world. Shipping is no different. So I'll leave the theme of this conference to be dissected, discussed by our panelists here, and we've got a huge set of extremely intelligent people here. Let me come back to the IMU and the IMEI. I do believe that the IMU can become the breeding ground for a lot of thinking, research, and research-focused development in shipping. The Indian mind is perhaps the most fertile mind in this part of the world. I think there's a lot that we can contribute. And I think that the start of becoming successful contributors to the global shipping learning environment can be these campuses spread across the country. Dr. Malini Shankar has spoken about it at various forums. She's committed to creating a learning and a knowledge-based environment at IMU. And we've been talking to her about how the IMEI, which is a learned body of 11,000 members, our membership is really the who's who of shipping around the globe, how the IMEI can work with the IMU to create an environment where learning and knowledge sharing is thriving. My dear friend Dr. Raju Balaji is at the helm at the Chennai campus of the IMU. I think we've got some fine people across these IMU campuses. It just needs a catalyst to revive the Indian art of thinking, of learning and knowledge transfer. I'm sure it will happen. I'm very keen to participate in this great project that we all have undertaken. And I think that in the days to come, the IMU will become an internationally recognized seat of learning. Ladies and gentlemen, thank you very much for inviting me to speak to you. I wish you have a great conference. And I hope this is the first of many that the IMU and the IMEI put together. Thank you very much. Have a great conference.
Thank you, sir. Indeed, it is very. Wait. Yes, sir. Indeed, it is very challenging to adopt the new technologies, as you said. So, on behalf of SNVT, I would like to thank you, sir, for providing your gracious presence to join us today to ensure our joy. With this, we have come to an end to the inaugural session. We'll be gathering here for the session 1 at 10:30. I request all of the paper presenters to be ready for the session 1. In the meantime, there are some standing instructions for the paper presenters. I hand over to Dr. S. Thangala to deliver the standing instruction. Ma'am, please.
So before giving the instruction to the participants, I thank Shri Uday Prohitji for his wonderful inaugural address. Instruction to the participants, we will be having session 1 soon. Before starting the session, we can have the following instruction. Let me read out for you. The participants are requested to be ready 15 minutes before the start of every session. Only the current participant shall unmute the microphone and switch on the video while presenting. Others are advised to mute the mic and turn off the video to avoid disturbance. The presentation time is limited. Therefore, the participants shall focus only on the key points and project their experiment or analysis part, as well as if any results that can be projected. There will be a time reminder from the anchoring team if the time limit is exceeded. However, the deliberation with the session chair, if any, may be continued. The paper title will be projected on the screen while calling a respective participant. Anyone from the team may present the paper. If there is no response from any of the presenter from a particular paper, then the immediate next presenter shall be ready for presentation. Any doubts may be clarified with the team using the chat box conversation instead of interrupting the ongoing session. Thank you for your cooperation. Over to Varun.
Yes, ma'am. Thank you, ma'am. We'll be gathering here for session 1 at 10:30.
10:35. We will make it as 10:35, Varun.
Sure, ma'am.
Yeah. Thank you. Thank you, all the delegates. Thank you, all the anchoring members. Thank you. We will meet again by 10:35 a.m. Thank you.
In the meantime, all the paper presenters of session 1, please be ready.
If presenters are ready, we can start immediately. Just will attend all the members, delegates, at least one session, if presenters are available.
So all the chief guests are here with us. All the session chairs are available for today's session. So shall we proceed on presenting the papers? Shall we proceed?
Yes, please.
Yeah. Thank you, sir. Varun?
Yes, ma'am. Yes.
Yeah, you can start over.
First session of the event is Marine Energy, Environment and Management, which will be guided by our session chair, Dr. Captain S. Bharadwaj. Before calling him, I would like to introduce him. Dr. Captain Suresh Bharadwaj pursued funded doctoral research in Denmark and UK and a postdoctoral thesis from the Greece. He is currently the resident director of Maritime Training and Research Foundation. He was the founder vice chancellor of India's first maritime university, MET at Chennai. He has work experience of 40 years, which includes 5 years as master and in command of various types of merchant ships. Subsequently, 25 years of multidisciplinary shore experience in senior and top management positions. So, with this, I would like to invite Dr. Captain Suresh Bharadwaj to start our session and say a few words. Sir, please.
Thank you, Varun. Good job. First of all, I would like to thank the School of Marine Engineering and Technology and the campus director, Dr. Raju Balaji, for this wonderful opportunity for me to chair this very important, the first opening session. And I would like to congratulate the School of Marine Engineering and Technology for taking this conference along with the prestigious Institute of Marine Engineers, the chairman, Mr. Uday Purohit. Thank you so much for collaborating. Wonderful. Good. So this first session devoted to energy, environment, and sustainable shipping. And both energy and environment are very key issues in sustainable shipping. And sustainable, ladies and gentlemen, is a big word. It's a very big word. We are talking about development without compromising with the pristine elements of this precious environment, which is so delicately balanced. And we have the responsibility of passing it on to the future generation in the same pristine state. We have no authority. We have no authority to spoil this environment and pass it on to the next generation. I am thoroughly inspired by Greta Thunberg, all of 17 years, nominee for the World Nobel Peace Prize. Very recently, she has donated 1 million euros for the cause of sustainable development. Good, ladies and gentlemen, let us get on with the session. We have 7 important presentations in this particular session. And let me tell the presenters, all the 7 of them, you have exactly 5 minutes. You have exactly 5 minutes to present your case. You need to incite the audience here so that they will be encouraged to have a good look at your paper and ask a few questions. And for the questions, just about 2 minutes are given. So let us start. Let us start with the first presentation. The first paper is a perspective study of shipbreaking in India and the impact of international conventions and regulations. And the presenter is Mr. Gopi Krishna Chokalingam. I am going to start my stopwatch now.
Shri Gopi Krishna Chokalingam, please respond.
Mr. Gopi, are you okay?
Sir, good morning.
Yes, please.
Good morning. Am I audible?
Good morning. Yes, please. Good morning. Welcome.
Yes, sir. Sir, please, you can take over and start.
Good morning to all.
Good morning.
It's my pride and privilege to take part in this conference and present a paper in presence of this august gathering. I'm going to present a paper on a perspective study of shipbreaking in India and the impact of international conventions and regulations. So recycling is the most efficient and sustainable way of disposal towards the end of useful life of a ship. It contributes to non-depletion of the existing resources and thereby the sustainability of the resources for the future. Entry into force of the several global environmental mandatory instruments and voluntary standards have prematurely sending the vessels for demolition. So recycling of ships is complex and governed by a great number of regulations due to its specific characteristics. In global perspective, in ship recycling, these are the 5 major recycling countries: Bangladesh, India, Pakistan, Turkey, and China. It is very significant to note that the top 3 countries, Bangladesh, India, Pakistan, share about 80 to 90% of the ship recycling of the whole world. So,
sorry for interruption. Please present your PPT so that everybody can watch it. Use present now option, sir, on the screen.
Oh,
yeah.
Sorry, I thought I was getting.
On the screen where you are watching, there will be a present now option near to turn on captions. Click on that.
1 moment.
There is a present now option, sir.
Yes, yes, yes. Sorry.
Yeah. Click on that, then you press entire screen.
Oh, yeah, I'm getting it. Is it visible, ma'am?
No, sir. You have to press your entire screen. Present now option. Click on entire screen. Again, you have to press on the window, share. Only then it is visible.
Is it visible now?
No, sir. Sir, you send your PPT to this email ID given in the chat box so that I can present for you.
Okay.
Sorry for the interruption. So got my email ID, sir?
No, ma'am.
So, see the chat box, sir. Look into the chat box.
Okay.
Look into the chat box. Could you able to see it?
Let Mr. Chokki.
Sir, shall we?
Ready. Meantime, we'll go for next paper.
Okay. The next paper to be presented, Puneet. It is on the title, New Regulation, Impact of Implementation of Sulphur 2020 Regulation on Seafarers. The presenter is Shri Ramdas Venkatarao.
Good morning. Can you hear me well?
Yes, sir. Very well.
Yes.
Can you give the? I'm not able to see the.
Yes, sir. Yes, sir. Yes, sir. Your video is visible.
Yes.
Yes. And your presentations.
Yeah, ready. It's with me.
Yes, sir. Yes, sir.
No. Where is the present screen for me?
Sir, in the bottom you have present now option, sir.
I got it.
Yes, sir.
Are you able to see my screen?
No, sir. Yes, sir. Yes. It's visible.
Good morning, all. Thank you very much for this opportunity. This is about the new regulations and the impact of Sulphur 2020 on seafood. This is pertaining to the IMO regulation, the MARPOL Annex 6 regulation 14.1.3, where there was a limit to the sulfur oxide emission from the ship's exhaust, which was implemented in 1st January 2020. So there were many similar regulations like SICA and others came earlier, but on a globe-wide cap was brought in recently after a lot of delays in the implementation. But they were very strict that it has to be brought from 1st January 2020. And though there were many options available, 3 can be considered as the main options by which this could be implemented. One is by using a compliant fuel. Compliant fuel, I mean, with a sulfur content less than 0.5% m/m. Or using scrubbers with open loops, closed loop, or hybrid models where the exhaust can be cleaned and have a percentage less than 0.5, or using alternate fuel such as biofuel or LNG or something, but still they need to comply with this requirement. The aim of the study is to analyze the problems faced by the seafarers prior to the implementation and post-implementation. Perceived by the seafarers have their concerns, and when implying with these regulations, and to identify the actual differences faced followed by the implementation. This is an exploratory study because the new regulation, and I did a survey, talked to the participants in that, and also did an ex post facto study of incidents that happened after the implementation till November. And the sample size is about 148. Convenient sampling was used. The mean age of the sample was 35 years. Sailing experience. I also had a discussion with experts who know well about these regulations and who can foresee the problems that may be faced in any of the methods that we implement. And a questionnaire was developed by the researcher, and with about 20 questions. After interviewing the experts and the seafarer, and then got it validated. The extent of concern over 2 of the models. I didn't take the third option of LNG or alternate fuel usage, either the scrubber or the compliant fuel. So was the candidates to mark a number between 1 to 10 based on their worry of concern in an Likert scale. And there was interview with the experts to know which system is better on their experience and what are the most problems that may be faced in the implementation. Then later, this all done in September 2019, and in January 2020 onwards, all the incidences happening over about some 220 ships are closely monitored, and they were all analyzed in this one. Okay, there were questions were made with a lot of concerns that have been identified, and there were about 11 concerns on the use of scrubbers and 12 questions on the use of alternate fuel. A statistical analysis was done, a descriptive mean, SD, and rank ordering was taken. The scrubber-related issues scored high mean of 6.78, and complaint fuel used got a mean of 5.14. The mean scores above 6.6 were highlighted in the next table. I am presenting on the next slide. And the significance level between the groups were also analyzed in this. So if you see the concerns that have been listed, this is common for both scrubber as well as for the fuel, complaint fuel. If you see that mostly the 6.6 and above score is seen only on the scrubber usage. And I could see at least more than 4 or 5 are there in almost identified by all categories, and in many of these concerns that has been marked. Then if you can see that these are the first set of points where those which would be happening only on the scrubber, where everything was high by all this team, and the next set of 4 questions were for the compliant fuel, which were relatively lesser compared to the scrubbers. Now, from 1st January 2020 until 15th November, out of 221 vessels on a company for 3 companies, we identified where 59 ships were fitted with scrubber and 162 ships were using compliant fuel. And total 45 issues were reported, of which 34 were scrubber related and 11 were compliant fuel related. The malfunction of the scrubber equipment happened to be the 21 numbers, and the leakage from the scrubbed water system was 6. Leakage from the seawater system was 4. The possible penalization is 1, and the work-related incident was 2. In fact, I must tell you that there was something which was not identified in the initial risk assessment all cropped in. Especially there was a minor fire in the yard when the scrubber installation was being made, and even that I have made it as a concern. Now, of the 162 vessels where the compliant fuels were used, 11 incidents were reported, of which 3 were pertaining to the fuel compatibility, 6 were on the issues on the machinery, and 2 were the work-related incidences. If you see the cleaning of the tanks with the high sulfur really posed a big challenge. The ship's crew were not familiar handling such a large quantity of sludge and discharging. In fact, in an incident while landing the sludge using some specific containment boxes, a minor spill also occurred on the jetty. So this is also one of the concerns that we found out. So the findings is that the scrubber installation as the means of complaints had higher concerns as expected by the seafarer, and the scrubber installation on board the ships were a major big project. It involved carrying large quantities of water from the sea chest to the highermost decks, and also the clean scrubber water, which can be acidic right up to the bottom. They all felt that if any leak, in fact, recent one video also was there at that time, which gave them a lot of scare, and this was considered as one of the problem. And same way, the complaint fuel usage, the main concern they found was what will happen to the machinery, because most of this machinery that are in use or the ships that are in use are built for high sulfur fuel, and there are some issues pertaining to the lubricity and the other composition. Now, the summary of the results and findings, it's the anxiousness due to the port street authorities who would verify the complaints happened to be the first one. I must say here that there was one circular that was given by the Singapore port that in case there is a non-compliant, then there could be some master could be jailed and all this thing. I think that is what could have been a bigger concern. The criminalization of the concern also came. Same way, pipelines passing through the engine room was their bigger concern. And of course, additional paperwork, which is coming for every new regulation. With the post-implementation, we saw that the scrubber system had been more difficulties than the compliant fuel. and mainly on the malfunction of the scrubber system, including some fuel trips, alarms, and various things. Same way, many new unexpected issues were faced during the usage of compliant fuel, especially some work-related incidents. And the conclusion, seafarers were able to foresee the problems that might arise in the new regulation. Even though many publications and guidelines were available for the easier transit to the new regulation, the organization and the seafarers experienced anxiety and stress prior to and during the implementation. The study implies that the organizations and industry bodies must consider more possible scenarios for the failures and develop related solutions to mitigate the same. The study also implies that the need of an associated studies such as making efficient models of scrubber, alternate means of reducing emission levels, technological solutions to machinery problems when using compliant fuels. And in fact, related reviews and theories, we went through most of the guidelines issued by various parties, IMO, IEPC, flag states, classification societies, OICCM, Intertank Condor, which enlisted the risk assessment and various other plans. And Fred Luthen's book that talked about the societal and the technological changes that can create extra organizational sensors, and other studies that says that uncertainty causes bigger stress to the people who are working in the front end. And also the new regulations, especially like, for example, a lifeboat hook. The lifeboats have always been considered as the one to save the life, whereas the hook models that came in had killed more people than it could save. Same way, the new regulations, MLC had a lot of concerns when it initially got implemented. The intention is good, like similarly the demonetization. The whole purpose was to bring in an end to the black money, whereas the people who suffered also included many of the different level sectors. The same way, the COVID-19 protocol, the lockdowns were really well implemented. People were all happy, but one section of migrant workers were really in trouble. So this is what actually prompted me to look into how the new regulations have got an impact and how the seafarers face it. And these are the relevant references. And I stop my presentation in case if you have some questions, please. Thank you.
Thank you, Captain Ramdas. I think, first of all, I must compliment you for the rigorous research which you have undertaken in making this presentation and the paper itself. Very topical and contemporary topic. It is well known that the newer regulation, more and more regulation coming, more and more paperwork, more and more work for the ship staff. And you will be, I must share this with you, that IMO is seized of this problem. There has actually been a research carried out by the Danish Maritime Authority on what is the administrative burden on ship staff, the useless paperwork which is done by the ship staff. And this is now embodied into the new rule making from IMO, that this industry is totally regulation driven. So they have to make the regulations in such a way that, like the energy efficiency regulation, it was in the basic principle that the administrative burden on the ship staff must not increase.
Yes, sir. That's the problem now. Every regulation adds up.
Excellent. Thank you very much. Wonderful presentation, Captain Ramdas. Any questions from the audience? Well, if there's nothing, then we will move ahead and we'll thank Captain Ramdas for this succinct, wonderful presentation, and we'll move on. I think we have Mr. Gopi back on. Or is it? No. Or we have Manisha. We have Manisha.
Sir, before proceeding, sorry for interruption. There is a query in the chat box with reference to the previous paper. It is from Shri Hare Rama Hare, IMU Mumbai Port Campus. He is asking how we are going to tackle the difficulties.
Yes, that's the reason I mentioned in the conclusion. It is very important when the new regulation comes, it is looked in all different aspects and be prepared. And like Dr. Bharadwaj said, there has to be and a comprehensive understanding, how it is going to affect the sea stuff. All these regulations, whichever we came in, I can talk more and more on this. It always gave only burden to the ship staff and to the operators and to the owners. There has to be a much bigger perspective. We are high hazard industry. A small error is causing huge problems. I would look at the training at the seafarers and all at the smaller-most level. It should be from the higher level, especially in terms of the authorities and the implementers need to look this perspective and then make it better. This is how I'm seeing it as a solution for this. Let me know that I have answered your question.
No, it's perfect. It's absolutely perfect. I think it is time we get away from training of seafarers to much bigger issues, because the ship staff is only a reflection of the big picture which is created by the company. So I think perfect. Thank you so much.
Thanks.
Yes, shall we move on, Dr. Thangalakshmi?
Yes, sir. We can move.
Okay. So our next presenter, the next paper is on hybrid energy systems and its impact on environment as clean and green energy. And who do we have presenter? Manisha? Yes, Manisha, all yours.
First, you will enter screen.
Yes, Manisha, we can hear you. We can see you.
Hey. Share.
Manisha ma'am.
Yes, ma'am. I'm presenting my.
There is a present now option. There. Yeah. Yes. We could able to see.
Mr. B. Mohan, sir, please mute yourself.
Yes.
Mouse problem.
Now you directly click on.
That's right.
Yes, right. Yeah, it's visible.
Yes, it is.
Madam, press F5. Yeah, you are on.
Good morning to all. This is Monisha Tikadar. I'm Monisha Tikadar from Kolkata. I'm a research scholar from Atal Bihari Vajpayee University, Bilashpur, Chhattisgarh. This is my first paper actually, so I am very nervous. My topic is hybrid energy system and its impact on environment as clean and green energy. This is my first slide. The whole world has been rapidly shifting to renewable energy over the last few years due to environmental degradation. Lot of heat is injected into biosphere from thermal power plant to exhaust gases and wastewater. The major problem is the effect of discharge of large quantity of heated wastewater into natural water basins. Hot water and greenhouse gases raise the temperature and disturb the natural ecological balance and human health. The plan is to have at least 175,000 megawatt of installed renewable energy capacity by 2022. But till now, millions of Indians are not connected to the grid system. Some part of India remains dark at the night. According to the data of Central Electricity Authority in the year 2019, India generated 126,759.09 megawatt non-conventional energy. Some of the world's biggest solar and wind power projects are now being built in India. At the same time, has a very high population, so it has to optimize land usage. Therefore, we plan system and use both solar and wind power in the single location. India's first large-scale solar wind and energy project has been built in Karnataka at Kavithal, Raichur districts. Hybrid power projects will end up providing to measured and optimized way to generate renewable energy, which help to make our planet green and clean. Now, question is, what is hybrid energy system? It two or more than two renewable energy sources is good together to provide increased system efficiency as well as balancing energy supply and environment. The main objectives to switch over from conventional to non-conventional hybrid power system: 1. Making the Earth's environment suitable for human habitat to meet the increasing demand of power. 3. Optimum utilization of land. 4. Improve the economy. The word solar means the sun, and solar energy means the energy of the sun. Each and every day, the Earth receives a huge amount of energy directly from the sun. Using specific method, we can utilize the solar energy. Solar energy reaches the Earth in the form of sunlight. In a sunny day, at noon, Earth received 1 kilowatt per meter square energy. India has a huge potential for solar power generation. In this map, we can see the western part of India receive good amount of solar radiation. India's goal is to produce 100 gigawatt of solar electricity in the year 2022. A solar panel works by allowing photons to free electrons from the atoms, generating a flow of electricity. We first noticed that King Hammurabi set up windmills to improve irrigation in agriculture in the 17th century of Babylonian civilization. Wind power mills produce electricity with the help of wind to provide the mechanical power through wind turbines to turn electric generators. The main parts of the wind turbines are rotor blade, brake, gearbox, controller, etc. Most important components used in the hybrid power system is inverter. The role of hybrid inverter is very important to convert the direct current DC into alternative current AC. There are different type of mode of hybrid inverter. For example, we have a sunny day from inverter power solar panel or wind
From INU,
solar and wind power directly toward load. If power breakdown happen during the night when the solar panel are inactive, then we take the power from wind turbines and also from the battery to fulfill our demand. To set up a hybrid power plant, it is more important to select the site to build the hybrid power plant. Basically, GIS is used to collect information. Now, the advantage of the hybrid energy system. Some hybrid system typically include both, which can simultaneously improve the quality and availability of power. There are limited operation and low maintenance cost. Hybrid energy system does not use any fossil fuel. It is exclusively renewable energy system. Disadvantages are most of the cases hybrid energy system is oversized. 1.3 billion population in India have to install this kind of hybrid power system. Is very difficult to find the site because land acquisition is a big problem in India. Still now 90% of energy supplied by the conventional sources. So there are a number of environmental issues, emission of carbon dioxide, sulfur dioxide, nitrogen dioxide. and particulates matter causes adverse effect on environment and causes of climate change. Thank you.
Yes, Ms. Manisha, thank you very much for your presentation. You were focusing on hybrid power, yeah, non-renewable energy.
Yes,
Yeah.
sir.
Okay. Any questions? Any questions from the audience? To Manisha.
Yes, sir. There is one question from Mr. Hare Rama Hare. I'm in Mumbai Port campus. With reference to solar power and wind power, which one is more user-friendly? Which one is having better growth prospect? Was the question.
Both are the useful, same kind of.
Madam, I have one question. Will both be giving equal power? What about the stability? Like wind is very seasonal, madam. Wind is very seasonal, and wind is delivering AC power. Whereas when we are harvesting power from solar, it being a semiconductor device, it is going to give DC power. So as of I am aware, for standalone, we can use solar, giving its best stable conditions, and your wind energy will be supplying at the time when the season is favorable, and it can directly be connected to the grid, right, ma'am? As far as grid connection is concerned, wind can directly be attached without any end devices. But when we are going for solar connected to grid, then we would be having some intermediate devices like converter and inverter section is mandatory, right, ma'am?
Yes, ma'am.
So as far as my opinion, I have like when we have a standalone project, then we can go for a solar. If at all it is a grid connected one, now we can hybridize thing, and there are many areas to be stabilized for giving this hybrid energy to the grid. But no doubt with this hybridization, definitely we could be able to make up the power compatible with the consumers. Yes, ma'am?
Yes, ma'am.
And for environment and clean green energy, both serve the same purpose. But for stability, there are many issues. But as far as environment and clean energy is concerned, both are good.
Yes, ma'am.
Yeah.
So Manisha, I think lessons learned are you need to raise the standard of your presentation. You need to do more research. What is new? There is no point in presenting what is already existing. So, so good. Thank you for your effort. We will move on.
Okay, sir. Thank you.
Ma'am, it was indeed a good presentation. You have covered a lot, like how we are going. We do have many projects on solar as well as wind, depending upon the community, where it is going to be delivered, like in hill station and all, what kind of energy is being done. So please continue your research. We are very much interested to see your another presentation in another forum. Thank you very much, madam.
Thank you, ma'am. Thank you.
All right, so we move on to the next presentation, which is studies on the impact on environment due to e-waste and refrigeration waste during specifically ship recycling process in India. And there is a way out, so claims Mr. Krishendu Das.
Good morning, sir, all of you. Can I present right now, sir?
Yes, please, all yours.
Just 1 minute, sir. Is it visible now, sir?
Yes, please.
Yes.
Good afternoon, all of you. Honorable VC, Madam, respected directors at Chennai campus, then Shivaswamy sir, and other extreme dignitaries. So before starting, I many thanks with Bharadwaj sir for your comment that we have no such authority to spoil our globe. So I'll take that point, and very short, as we have given only 5 minutes and 10 slides, I'll try to give this presentation. So, is it visible, sir?
Yes, please.
Okay, thank you. So what happened actually when you go for seed breaking? So if I say concern in India, it is one of the biggest industry in India because seed recycling process. And there are so many small and big seed recycling industry throughout the coast of India, near about 150, whether it's a big or small. So just to know, when you go for seed breaking industry, first of all, you will find the Gujarat in Alang. Then we have some Maharashtra, means Mumbai, Dharukhana, then Calcutta, Khidirpur, then Andhra Pradesh, Vedaravu, then near Kakinada, Kupala, so many seed breaking industries are there. So, if we go, total world seed breaking, whatever industry is going on, around 33% only in India or more than that. So this industry is very chain relation with other industry for recycling, steels and other commodities which is coming out after the breaking process. So here we have this one magazine, you can get so many things are there, where India you can find out around 26% of the Stone Age, you will find out this is your scrapped in India. If you go for this one report, then you will find out in 2015 275, 2016 249 like this, and 2020 up to third quarter 129 ship already in the process and already done. Even COVID-19 situations are there. Then we can get what is the figure is going on seed recycling process and what is the effect actually. So there are so many effects. Today we are just for the slide we will be discussing some refrigeration effect. Here you will find out, if we go for about 80% of these ships are containers, oil tankers and bulk carriers and general cargo ships. And if I think about what refrigerant are using, if we go for these ships are average life around 25 to 30 years, and that time normally CFC, HCFC refrigerant are used, which is mainly R12 or 22. And if you calculate simply in our household refrigerant, it is 0.225 kg of refrigerant. That is, I'm talking about 165 liter refrigerant. Then you think about ships. I have given some values. It's the average and smaller side. Passenger ship, medium sized passenger ship. For AC unit, is 600 kg is required. For provision 120 kg refrigerator, 50 kg roughly. Bulk area 70 kg. And like this provision 20 kg, and so many refrigerators are there, that is portable refrigerators are there, deep freezers are there, near about 5 kg minimum I am talking about. So if I go for average, that is I am considering the lower side, every seat at least 100 kg of refrigerant are used, which is 35 years or 30 years old or 25 years old, where Montreal Protocol as per convention, we know that time HCFC and CFC refrigerant are used, mainly R12 and 22. So now, if you go for Montreal Protocol, you can go find out this, phase out all these. Sorry, this I can reduce. So refrigerant plus Montreal Protocol, now we are going for higher, obviously, environment-friendly refrigerant. But if you go back for 1931 to 1990 and 1990, you will find out CFC and HCFC used, where is a fluorine and chlorine based. So this, what is pollution actually, what is coming from this one, you will find out. One thing, India has entered in Hong Kong Convention in November 20. And Hong Kong Convention says how you categorically or how you control these, not only control, how you audit all these seed recycling process, all these commodities coming out, which will go for all for your environmental effects. So now if I go for that, you will find out actual happening what is there. There is no collection record of refrigerant from the ships, no release record of ships when they are breaking these refrigerant unit, pipelines, all these. No record of in-house disposal using special type of incinerator. Remember, this R12, R20 we cannot use anymore. But somewhere we have gone through the some shipyard, we have found that there is some record that refrigerant has been recovered. But after that, what is happening to the refrigerant? Because that cannot be used. And frankly speaking, there is no such disposal facility for any shipyard in India. then that system is open loop. Here, in Hong Kong Convention, nothing is mentioned here what to do in this open loop system. Simply release refrigerant directly to the environment, whether it is breaking 50% or 20% or 25%, even 10% release of refrigerant. Because we are thinking when they are breaking, these people are not trained. The management also have paperwork that only they have collection of some portion of refrigerant, but what is happening after that? They are saying we are handing over to the source authorities. So when we have incurred that source authority, they are using, sir, we are using again in the small refrigerant portable units, which is banned actually. There is no disposal facility in the workshop also or source also. That is an open loop. That means finally it is directly releasing to environment. So one small calculation I have given. Suppose 2020 we have 129 ships already scrapped. So total refrigerant average 100 kg. If I say I'm not going for higher side, that is total refrigerant is 12900. If 50% release, for safe purpose, I am saying about that is 50% refrigerant is released during the ship breaking process, then it is 6450. What is GWP? Because I am considering this is CFC because ships are old, around 30 years old, and that time all ships use R12 and R22 maximum. So if I consider CFC, chlorofluorocarbons, then we will find out just for lower side, GWP, global warming potential, 70305 ton equivalent CO2. That is your warming effect. ODP 6.54, okay, that is okay. If it is 25% release uncontrolled, means during ship recycling process, all the appearance unit, all these AC unit, or all these domestic AC unit on the vessel, then it is 3225, 25% release. That means your GWP equivalent CO2 35152 ton. Remember, this is ton. That is equivalent CO2 release is 35152. That is your warming effect. And then if you go for 10% release, even I am saying okay, everything okay, they have controlled, that is 10% release. Still, you will find out the CO2 equivalent for the 2020 financial year. Even fourth quarter is remaining. The GWP equivalent CO2 is 14061 and ODP 1.290. This is our scenario. I am not going for backside. The calculation is very simple, and this calculation is lower side. I am not considering any passenger ship here. So now, this is the scenario of CFC released, which is coming up the year every recycling process in India. Environment effect, that I will not discuss too much. Chlorine, chlorofluorocarbon, chlorine is there. When this CFCs and HCFC on the base of a surface, there is no effect. But when it goes for stratosphere, then it has bad effect with this ozone layer. This chlorine affect the ozone, breaks the ozone, and there is hole. So that is your idea of this ozone breaking process. That is very everybody know. So one chlorine molecule, just think about one chlorine molecule breaks about 100,000 ozone molecules. And that is happening every year in our ship breaking industry. That calculation already given, that is minimum side. What is the effect? All of us know very easily: sunburn, skin cancer, cataracts, and other skin eye damage, obviously direct, indirect effect. Aims towards smiling globe. So I have told already so many CPR, small and big, which is ship breaking years along our coast, which is 30% total stack. It is important for Indian year to select the right partner to work with the order. That means we have to do some proper way with the industry where our CFC and ACFC disposal unit must be in cooperation. Audit, every point we have to do audit, and next page I'll send what to do our process for our research and all these. So what I have to do, how we have to do handling and other process. Identification, refrigeration, AC equipment for recycling process, that is Hong Kong Convention is there. Already we are in India already entered. But risk cover recycling using certified equipment, okay, that is also there. Disposal procedure, now this starts our convention does not mention here what is the detailed disposal procedure about 20 years ships which is CFC and ICFC used. No risk assessment related. And then refrigerant to reclaimer, even that is reclaimer, what is the use after that? That is question is open loop, not closed loop, because if it is closed loop, that to be destroyed or disposed properly. An environment awareness training program of workers staff must be required. That is also very lagged during our visit. We have seen nobody knows about what is the actual effect. Even some management level officers, I'm not blaming because this is the actual fact. They don't bother about also. Even our go for convention, they are also in paper convention that is only for your audit and how much they are collecting. What is actually having for disposal, no records, nothing process is there. The training is requirement to be considered as a certified person, monitoring, record keeping, disposal of refrigerant from ship recycling, even if it is received by the industry or source industry, how it is used, whether it is disposed proper way or it is just used for other machineries. There is no record, nothing is there, so loop is open still. That means all these refrigerant directly or indirectly is released to the environment. Every ship breaking yard must have disposal facility or refrigerant waste, that is your high incineration process. It is not so very costly. And there are three processes very effective, which is maybe disposal with incinerator or high temperature incinerator, where that is plasma plant with your arc system, 10,000 temperature is maintained, and these CFC and ACFCs are broken, and this separate all these molecule is used as for raw material that is not released in the atmosphere. That too should be installed in everywhere. That is my target, and we have to do all together this work, and this is my reference, and it is a hard work, but we have to work from heart. That is my presentation and research topics today.
Thank you, Mr. Das. Thank you so much. Very, very well put. The chemical industry is required to have something called responsible care. Yes, before sir. Coming out with any chemical, they are required to do a complete life cycle assessment. Correct, yes, sir. On even the disposal and recycling. But of course, like when these gases came out many years back, it was absolutely magical. Nobody ever thought that this is going to make a hole somewhere in the ozone layer. Right, but excellent project. I wish you all success in this. Any questions? Any questions from the audience?
Good morning, sir. I have put my question here. Do we expect after Hong Kong Convention on recycling of ship, it is expected to improve the condition?
Yes, Mr. Hararam, thank you for your question. It is a very genuine question, But if you go for detailed Hong Kong Convention, the system is still open loop. The Hong Kong Convention is not saying because for these 30 years old ship, which is CFC and ICFC used, how to destroy, how to system is closed loop, what to be records. The records only for your collection and declaration, but destroying method, that is as Bharat sir already said, life cycle all this system, that is still open. So we have to do this work again, how to do that. Obviously, you have to follow Hong Kong Convention, but this disposal method must be specified.
Thank you. Anybody else? All right. I think we should move on. We've got still, I think, 3 more presentations to go. Not much time. So, okay.
We received the PPT of the first presenter, Gopalingam sir. So, okay. Yes.
All right. So we are back with Mr. Gopi for his presentation on a very similar topic on shipbreaking. Mr. Gopi, all yours, sir.
Good morning, sir.
Sir, I will present your PPT.
Yeah, okay, ma'am. Okay. Apologize for for taking your time, wasting your time. In fact, so
yes.
Yes, sir. You can proceed.
So it's my pride and privilege to take part in this conference and present my paper in presence of this august gathering. So my title is A Perspective Study of Shipbreaking in India and the Need Towards Effective Implementation of Hong Kong International Convention. Recycling is the most efficient and sustainable way of disposal towards the end useful life of a ship. It contributes to non-depletion of the existing resources, as Captain Bharadwaj sir said in the beginning, and thereby the sustainability of the resources for the future. We have to think of the future. Entry into force of several global environmental mandatory instruments and the voluntary standards have forced premature demolition of ships. Recycling of ships are complex, and then it's governed by a great number of regulations due to the specific characteristics and nature of the industry. In a global perspective, if you see the ship recycling, the top 5 recycling countries are Bangladesh, India, Pakistan, Turkey, and China. The first 3 countries, Bangladesh, India, and Pakistan, are recycling at about 80 to 90% of the world's recycling at present. So Bangladesh was a clear market leader during the period 2014 to 18, followed by India, and then by Pakistan, Turkey, and China. China actually has dipped from its second position to the last position due to the fact that there is a lot of environmental measures taking place in China. They have banned the import of recycling of ships, foreign ships, and closed down many recycling industries as well. Whereas India, it has slipped from its top position to the second position from 2016 to 18 due to the very reason that we are also taking equal steps to adhere to green ship recycling, that's safe and environmental friendly recycling. Next slide, please. So these are the major legal framework: the Basel Convention on the Control of Transboundary Movements of Hazardous Waste and the Disposal of 1989, the ILO guidelines which specifies about the living and working conditions in the ship recycling industries, the Hong Kong International Convention for the Safe and Environmental Sound Recycling of Ships 2009, and the EU SRR, that is European Union Ship Recycling Regulations, enacted in 2013. So the entry criteria for Hong Kong Convention is that there has to be 3 separate criteria. That is, first criteria is ratification by 15 states, and the second criteria is that it must represent, the member states must represent 40% of the world merchant shipping tonnage by gross tonnage, and the third criteria is that the combined maximum annual ship recycling volume should not be less than 3% of the combined gross tonnage. At present, the status is that the first criteria has already been met. The second criteria and third criteria are yet to be met. So the timeline of EUSRR is that the 31st December 2018, all new ships of 500 GT and above flying the flag of EU and EEA shall carry an inventory of hazardous materials on board. And with ships which are to be recycled during that period, it has to have a ready for recycling certificate, and it must be recycled only in the EU vessels, the list of EU ship recycling yards. So the next mandatory line is that the 31st December 2020, it is quite very close to us. The ships flying the flag of EU and EEA and third-party ships visiting the EU, EEA ports and anchorages shall have a valid and certified IHM on board. At present, many of the flags are issuing SOC on this regard. Next slide. So, Indian perspective, India has acceded to the Hong Kong Convention and home to the largest shipbreaking facilities in the world, over 200 yards along its coast. Along-Socia Belt is one, which is nearly about 95% of the India's ship recycling, and about 6.2 million GT is scrapped in India everywhere, which accounts for about 33% of the total scrap tonnage in the world. Next slide, please. So the issues at present in the island shipyard are that the environmental pollution caused by the beaching method, which is not acceptable for EU SRR, European Union Ship Recycling Regulations, and for no formal education or adequate training for the workers, and the labor rights violations are taking place. It's a labor-intensive industry, inadequate work process and safety procedures, inadequate downstream waste management. That is also a point of concern as far as EU SRR is concerned. So presently, about 43 yards, including 34 facilities located in 12 EU member states and in Norway, 8 facilities in Turkey, and 1 facility in the United States of America are in the European list of approved yards. It's quite sad to be noted, and a point to be noted, that even a single yard from India has not qualified to be in the EU approved ship recycling yard. So that is a matter of concern as of now. So the mounting pressure from NGOs and the financial institutions, the EU ship owners are forced to follow a responsible approach towards ship recycling. And European Union ship recycling regulation mandates that the EU flagged ships must be recycled only in the EU list of approved yards. Right now, many of the European ship owners are circumventing the regulations and sending the vessels to India for demolition by choosing some flag of convenience. So right now, the European Union has noticed that and trying to provide some incentive schemes for the EU ship owners who opts to recycle EU approved list of yards. If in case HKC not coming into force immediately, this could end up in a chance for the acceptance of EU SRR by the EU ship owners. That means a huge loss of business opportunity, considering India is recycling almost 40% of the world ship tonnage. So to conclude, there is a need for the related government organizations and agencies in combination with the academia to do more research activities and development in the area. And that could project India as a safety conscious and environmentally friendly sustainable industry, and would go a long way in consolidating India's position as a market leader in the ship recycling industry. At present, with the, as a major step on 15/10/2020, the central government has notified the Directorate General of Shipping as the National Ship Recycling Authority to monitor and approve ship recycling. So, at present, with ex-DG Shipping and Chairperson of National Shipping Board in the helm of IMU, there cannot be a better moment for the ship recycling industry. So this is the right moment, and we have to step up all our research activities in this angle and try to implement the convention, Hong Kong Convention. And as we have our own ship recycling code 2013, that has to also to be taken into consideration very much. Also, we should bridge the gap between the Hong Kong Convention and EU SRR in our yards and try to get the market position as a top leader. So that's all from my end. Thank you very much.
Thank you. Thank you, Mr. Gopi. I think you've identified the issues very, very properly with respect to the shipbreaking issues in India. And we wish you all the best with your research in this area. Any questions from the audience?
Thank you, sir.
Yes.
There is one question from Sri Hare Rama Hare. Now India is signatory of HK Convention and DG shipping has been given authority. What are the improvements we can expect along scrapyards?
So it's a good question. Thank you for the question. We, as DG Shipping, has already brought up a lot of revolutionary changes as far as Indian shipping is concerned. And this is the right moment, and DGS has taken over the mantle. We can expect that DGS will monitor the recycling and approve the ship recycling industry, ship recycling facilities to the tune of Hong Kong Convention, and will try to bridge the gap. That is what we expect, and definitely this is going to happen. So it is not very far.
Yes. Yes, I believe some of the shipyards, some of these breaking yards are already certified to, I think, OSHA's 18,000 or ISO 45, but none of them have gone for ISO 14,000. Really, isn't it?
Yes, sir. Exactly, sir. That is also a sound environmental management system is also a requirement as per EUSRR, and okay. they have to work hard in this angle to into ISO 14,000 series, ISO 14,001 also. All our yards have to come up.
Yes, sure. Yeah, some efforts are there towards health and safety, which I believe are certified already, but I think environment will be the major issue.
Yes, sir. Yes. Right now, the IAX class or many of the IAX class are giving SOC for the Hong Kong Convention. And very soon we can bridge the gap, and we have to really work hard and put more research activities in the area to come up.
Very well. Thank you very much, Mr. Gopi, for your wonderful presentation. And we'll move on. We will move on. Fifth presentation here now on air bubble lubrication for the hull. Yes, one more step towards energy efficiency. Mr. C.P. Balaji, all yours.
Good morning, everyone. Am I audible?
Yes, please.
Okay. I am C.P. Balaji, Assistant Professor, Marine Engineering of IMU Chennai campus. I am proud to present the paper in the presence of this learned gathering. This paper I have prepared along with Dr. K. Sivasamy sir, Head of School of Marine Engineering and Technology, IMU Chennai campus, and also he is the convener of this e-conference. With this guidance, I like to move further. This is about air bubble lubrication for hull. Actually, this is not a research or research work. This is only a review of various papers, because this is my first presentation or paper presentation, and I have done a review of various papers, and I have consolidated all these papers, and I have come to a conclusion like. Which may be helpful to all others.
Okay.
This is not I want to remind again, this is not any research. This is only a review of various papers.
Understood.
Reduction of hull frictional resistance and increasing of propulsive efficiency are the major drivers for ship designers, both for economic reasons and for reducing pollution by ships due to emissions. And in this way, we see the reduction of frictional resistance of the hull by air injection below the ship in combination with special coatings. It's an active area of research. Though we have tried to do air injection, we have to have special coatings. Special coatings themselves are not sufficient to have reduced the frictional resistance. To some extent they are doing, but now the area of research is to add to that. We require some other means to reduce the friction resistance of the hull, which they are doing by air injection below the ship's hull. This air lubrication method is a technology to reduce hull friction resistance by sending air to the bottom of the hull, which creates a layer of air bubbles between the hull and the seawater. There is a formation of air bubbles between the hull and the seawater. This air bubbles will reduce the frictional resistance of the hull. This paper reviews about various techniques by which air bubbles are created and they are sent below the hull. They are like air micro bubbles, air cavity, second one is air cavity, and the third one is air film or layer formation. First one is air bubbles, micro bubbles, and air cavity, and then third one is air film layer formation. In air micro bubbles, we are having two methods are there. Presently, they are doing research and in small vessels. They are doing research in small vessels, not in big vessels. Small vessels. In the air micro bubbles, we have creating the micro bubbles using hydrofoil air pump. By this method, the micro bubbles are generated using bubble generator, that is hydrofoil air pump, and they are sent underneath the hull to form the layer which will reduce the frictional resistance. But in this method, you see there is a need for production energy required for producing the air bubbles. We require conventional bubble generators which require energy. So next step ahead, they came out with another method which without using the energy or bubble generators, they can produce bubbles. The same micro bubbles, smaller bubbles. That is called winged air induction pipe technology. This winged air induction pipe technology has a angled hydrofoil with an air introducer. With an air introducer, it has a winged hydrofoil. When the ship moves ahead, that is forward direction, it is designed in such a way only in the forward direction, not in the aft direction, because in the aft direction we use only in the entry of port or during anchorages, that is maneuvering time. So mostly ship will be moving in the higher direction. So these winged air induction pipe are fitted in such a way when the ship moves in the forward direction, a low pressure region is produced above the hydrofoil. This low pressure region sucks the atmospheric air and into the hydrofoil introducer, and it sends inside the water. And this air forms into a micro air bubbles, very small, say in the range of 10 microns, and they reduce the buoyancy. This smaller sizes reduce the bubble buoyancy also. This is causing the air bubbles will reduce the frictional resistance. And compared to the previous method, the hydrofoil air pump method, this micro bubble size is almost 1/100th size. So this size also, these air bubbles, once they have created, they have found that once ejected, the size of the micro bubbles doesn't change. That is one important thing. Here, this one we can see. This is the angled hydrofoil, and this is the introducer. Once the direction of flow is like this, the ship is moving in the forward, and water flow is like this. Air is sucked from top, and it causes the air bubbles, release of air micro bubbles. This hydrofoil size is around 40 mm. This was the small experiment done on a cement carrier. And this is where it was fitted in the dry docks. And a closer look of this winged air induction pipe fitting is shown like this. This is cast iron fittings made of cast irons. And this is about, you can see this is the bubble generator, this one winged air induction pipe technology method. And there is a graph drawn against y-axis we take shaft power, and on the x-axis speed of the vessel. And they have done experiments like increasing of the speed and increasing of the shaft power. And for each speed, they have taken what is the shaft power. One with air injection and other one without fitting of the air injection. This we can see speed, more speed with less power, more speed with less power in case of air injection. In case of no air injection, the ships which are not fitted with that, the same ship which is used for experiment before that, here you can see the speed. For more speed, you require more shaft power. That means more fuel. More fuel you burn, more cost, as well as more emissions and pollution to the environment.
Yep.
And this is the second method about air cavity. In this, air discharge from the blow-off portion mounted on the bottom of the hull. And this air discharge converts into air bubbles due to the tearing forces of the surrounding flows. These air bubbles moves towards the stern. That is, this blow-off portion is mounted on the bottom in the forward, almost in the forward or slightly after the forward, and these bubbles move towards the stern, covering the bottom of the hull, thereby reducing the frictional resistance. You can see here, this is the forward portion, the stem, and this is the aft portion of the ship. And this is the air blow-off portion, and air bubble flow is in this direction.
Mr. Balaji, sorry to disturb. You can give full away from half again.
Last one, sir. And this is the last one, air film layers. And this concept can be seen as a combination of micro bubbles technique as well as air cavity system. There is a spelling mistake, okay, sorry. The air stream is injected into the bottom region of the ship, and air film is formed. But this air film thickness is about 0.5 millimeter. These all experimental things they have done in the small ships. And this will reduce the frictional resistance. But when they're doing experiment, they found there is a difficulty in maintaining the stability of the air film formed. So, okay, conclusion is we have to go further and do some research on this type of things, which will add to the reduction of frictional resistance of the hull, thereby reducing fuel consumption. Thank you.
Thank you, Mr. Balaji. Thank you so much. Any questions on this?
Yes, sir. There are questions. Which technology has the potential to be implemented in near future? What hinders now for its implication in real time?
Is the question clear, Mr. Balaji?
Yes, I got it. Actually, the wind air induction pipe method can be used because it doesn't use any energy for the production, but the ship's speed is very important now. The ship's speed and the where to fix all these things, because it will be ballast condition and then we have the loaded condition. Difference in ballast condition and loaded condition, the ship's water line changes, and then another one is the speed of the ship. Nowadays, due to slow steaming, we are going to reduce speed. So we have to do, first they started with normal speeds. Now slow speed also introduced. So there is a area of space for research in these things.
There is another question, sir. The air bubbles leaving the hull surface. Just a moment. The air bubbles leaving the hull surface flow into the ship's propeller. This can influence the efficiency, noise, and vibration of the propeller. How can we overcome this problem?
These things are still under research. That is also the cavitation effect may be forming, and these air bubbles may strike on the this propeller blades also. That is why these are all micro bubbles in the size of 10 microns. So they're trying to do some research how to go about that. Still research is going on.
So there are some suggestions from Dr. Sudhir. Experimental research work on this system has been carried out in IIT Madras by the undersigned, that is by Dr. Sudhir. Kindly go through those details as it yielded in 46% reduction in the drag of ship's hull. And one more suggestion from Mr. Anirban. In order to obtain the desired effect, it is important that air bubbles are of uniform size and are evenly distributed beneath the hull surface. Moreover, a change in air bubble diameter would drastically affect the air bubble distribution beneath the hull. How can we control the bubble sizes? There are questions and suggestions. I hope we are running out of time. These chat box questions will be taken into account, and the same would be submitted to Shri C.P. Balaji, and he would be contacting you through mail. Thank you.
Thank you everyone for the opportunity. Thank you.
Thank you, Balaji sir. Thank you so much. Okay, we will move on. We'll move on to the next presentation, which is on port security management. And the presenter is Shashwat Dev. Yes, please.
First of all, a very good morning to one and all present here. My name is Shashwat Dev. I'm a cadet in IMU Chennai campus, and I, along with my co-author, Cadet Mrinal Nigam, will be presenting the paper on port security management. I'll just present the paper first. I hope the presentation is visible.
Yes.
The paper that we stand to present before your learned self analyzes various facts and figures pertaining to the security of a port. We also discuss measures that could be instilled to improve the process of cargo handling on port. It is fairly established that port is one institute that remains the entry point for national trade. Since the beginning of history, sea has served as trade routes and ports as a junction of cultural and financial exchange. It is therefore imperative for any country that wishes to extend its economic influence to protect its maritime interest. The growing maritime traffic and ever enlargement of demands only adds to the stress. The monetary exchange involved in the activity increases the potential threats to the ports. Hence, security and proper management can aid to preventing any disruption in the smooth growth of a nation. Ports, just like airports, can act for an entry of an epidemic into a country. With the plethora of containers and various resources, it all comes down to the efficiency in managing and the security of the port. Effete practices are something that is very characteristic of a human and depends upon an individual's moral values. Security management can be made more efficient by reducing human presence and increasing the process of integration of technology to various port-related activities. Technological resilience intertwined with human supervision will define the future of port operations. Volume of trade handled through sea is immense, which roughly amounts to about 90% of the total cargo transported around the world through various means. Port traffic intensifies at 6 to 8% every year. The capacity of 13 major ports in India is likely to increase to 1,459.53 million tons by this year. Investments worth $7.7 billion have been approved in the last 4 years that quantify to 118 maritime projects. Billions of dollars are involved in an industry that handles major portion of the global trade. It is therefore only befitting to improve methods of cargo handling and the security of the port with proliferation of traffic. Traffic management in ports help in improving the efficiency of port security. The global traffic at port is increasing every year. Countries like China, Singapore, South Korea, United States, etc. are among the top world container ports. Handling millions of TEU traffic per year also increases the amount of global money that is at stake. Based on a study conducted by the Alliance in 2018, 75 to 96% of maritime related accidents are caused due to human error, such as inadequate training, fatigue, negligence, etc. These oversights have cost around $1.6 billion in losses from 2011 to 2018. Computerized port management can reduce these losses to a great degree. Automation of activities that are otherwise handled manually can increase the efficiency and reduce risk to the port. The ever-growing traffic needs to be managed by an ever-evolving port management system.
When we are looking into the finances that are at stake for any port-related activities, we should also consider the losses that companies or respective stakeholder would incur in case of an attack or a calamity. Here's a fact. In 2019, the global economy grew 30%, which means about $87 trillion worth of economy was taken by the world. But as we all know, some major incidents like 9/11 or the attack in Taj Hotel have shocked the world. It has also led the IMO to develop, recommend, and implement a set of security measures applicable to ships and port facilities. These measures are called ISPS, which stands for International Ships and Port Facility Security Code. The ISPS contains guidelines for PSA, Port Security Assessment, and PSP, Port Security Plan, which will provide a set of standardized global framework in marine field. An assurance to ship owners that adequate security measures are taken in place for their ships. Data to various countries which have subscribed to these codes to evaluate, assess, and detect security risks to the ships. Identification of the nature of expected traffic into or out of the port. As we all know that threats aren't only physical, but they could be cyber security threats as well. According to a report by Clear Sky, a cyber intelligence company, if there is intrusion in the system which carries the detail of container moving from point A to point B, it could cause a loss of hundreds of thousands of dollars. And in order to fix that problem, if we close the port for a day, it could cost around $1 or $2 billion. To curb such threats, we can adopt methods, some of which are already in place in the port of North Chinese city, Kafadian, or on an experimental basis with promising results. CCTVs should be installed at every accessible areas. No blind spots should be there in any corner. Those who enter the port should be given microchip installed identification card, which will track location all over their visit. A quick reaction team, QRT, should be kept in standby mode to reach the crime scene and handle the situation as soon as possible. Now we suggest an automated locomotives should be implemented, which will move cargoes between path specified location given by an office central system that in turn specifies the path of the locomotives using GPS. This system will also look into real-time traffic on ports to make sure serious accidents are curtailed. The locomotive reaches the section of the port from where the cargo is transferred with the help of cranes. Trucks should be employed only at the outer campus. This method will cut labor costs by 70% and increase efficiency by 30%. It is vital to safeguard the ports as they play a significant role in economy. Thus, technology simulation can curb losses to a great extent. Thank you.
Okay, thank you, Mrinal. Any questions on good effort by his? Which year are you, Mrinal?
Sorry, sir.
Which year?
Sir, I am in second year.
Okay, okay.
I and Shashwat both.
Okay, both are you in second year. Yeah.
Yeah, we are classmates.
Good. Okay.
Yes, sir.
We can proceed to the next one. Yeah, we'll go to the last. We have already overshot the time. So let's come back to the next presentation, which is again on port security management. And Ms. Uma.
Hello to one and all. Shall
Yes,
I go?
Uma.
Shipping today is one of the safest form of transport. Every day, the global fleets carry billions tons of cargoes across the miles of ocean with less than 0.001% of accidents or incidents. Let's straightly go to my presentation. Port security management system with respect to Indian ports. Let's have a quick agenda. International regulation, SOLASs and maritime security, port security training, maritime security regulation and budget analysis, challenges and suggestions. Let's get to the topic international regulation. Everyone is familiar with the traffic regulations, and the ships also have their own rules of regulations. In 1972, IMO adopted international regulation for preventing collision at sea, known as Coleridge. The IMO safety standards are improving continuously to provide a safer workplace for the seafarers and protecting the environment too. The maritime security related emphasis of IMO work became evidently in the year 2002. By the end of the same year, IMO adopted a major security related amendment to the Convention of Safety of Life at Sea called SOLASs. The International Convention for the Safety of Life at Sea, namely SOLASs, it was first adopted in 1st November of 1974 and entered into force 25th May 1980. The SOLASs Convention is regarded as the most important of all international treaties concerning the safety of merchant ships and ports. The current SOLASs Convention includes an article setting out general obligation, amendment procedure, and so on, followed by an annexure divided into 14 chapters. Among them, Chapter 11 and Section 1 are specially measures to enhance the maritime security, detailing the requirements for radar, GPS, depths, electronic charges, and many others. This chapter clarifies the requirements relating to authorization of recognized organization, such as responsible for carrying out surveys and inspection on administration behalf, NAC surveys, ship identification number scheme, and port state control on operation requirements. The regulation section 11(2) and 2/3 of this chapter enshrines the International Ship and Port Faculty Security Code, shortly ISPS Code. ISPS Code. What is ISPS Code? The ISPS Code entered into force merely 18 months after its adoption by the Colossus Conference in December 2002. In response to the event of September 11, IMO work has resulted in amendment to SOLASs Chapter 2 called ISPS. It has two parts, mandatory part called Part A and recommended part called Part B. These requirements are set to be mandatory from July 2004 for all the ships, including passenger ships of high-speed craft, cargo ships including high-speed craft of 500 gross tonnage and above, mobile
Can you talk
offshore...
about the Indian ports? Can you talk about the Indian ports? Can you skip these introductory slides and go to the Indian ports perspective?
Yes.
Yes, please.
Yeah. We have the Maritime Security Regulations, sir. The Maritime Force created under the Coastal Surveillance Scheme that was launched in 2005. The Government of India also launched, with respect to coastal radar chain, the Automatic Identification System and Vessel Traffic Management System. All these are adopted for the protection of national coastal line from uninteracting vessels. The personnel of Central Industry Security Force coordinated in joint operation with the Coast Guard, the Indian Navy and the Marine Police to face the threats from the sea front. From the above discussion reveals that there are different ministries associated with major maritime legislation. We also have Indian Port Act 1908, the Major Port Trust Act 1963 and the Major Shipping Act 1958, the Ministry of Defence Authority for the implementation of Coast Guard Act 1978 and the Maritime Zone Act 1976. Then coming to the National Automatic Identification. We have Director General of Lighthouses and Lightship lays the foundation of National AIS network by establishing 74 stations on exciting lighthouse along the Indian coast. And also we have a tracking of SOLAS vessels carrying out the transponders as per the Director General of Shipping Notice. And we have a biometric cards for the coastal shipments to establish a national marine shippers database, which can be accessed by authorized agencies, both central and state union levels. Coming to the Coastal Surveillance Network, the Coastal Surveillance Network has been found out by the Indian Coast Guard comprises a sequence of statistic sensors having radars, automatic identification system, day and night cameras, and med sensors at 46 locations along with the coastal line and island. The objective of vessel traffic services achieved by integrating variety of sensors like radar, receiver, GPS, direction GPS, hydrological and meteorological sensors, which give an overall geographical picture of the world to reinforce the maritime domain awareness. The intention of the Coastal Survey Scheme is to strengthen the infrastructure of patrolling and the surveillance of the shallow areas across the coastal region. And we have RFID tags, which offers to visibility of the real-time cargo movement, and we can track a cargo, a container, vessel, whether it is berth or whether it is in anchorage or whether the container has moved to the CFS. We can check it very easily.
Okay.
Whatever we trying to do, we need budget. In coming to the budget analysis, in a 10-year blueprint of maritime sector is released by the Prime Minister of India in the Indian Maritime India Commit Suit in November 2020. As per the Union Budget 2021, the total allocation for the Ministry of Shipping stands at rupees 1,800 crores. The Major Port Authority Bills 2020 was introduced in the Lok Sabha, which intends to provide regulation, operation and planning of the major ports in India, which are mainly leads to build the infrastructure of ports which make the Indian ports into a world-class port, aligning with the maritime vision of 2030 of the Ministry of Shipping. And coming to the challenges, threats to the coastal security are different and highly complicated. Threats, terrorism is up to date a big threat globally. It is not only a threat for a particular region, country or a society. Then coming to the criminal activities, actions including like smuggling, theft, violating the trade regulations, and also the actions of criminal activities that took place in the port domain like weapons handling, drug dealing, extortion, violating the trade rules and customs rules. These are also major threats we are facing, and even the loss of containers and money hijacking in the vessels, this has also been a big threat. Coming to the cyber security, the very important thing is here to understand the cyber attack is not only just attack our data or a company information. The customs details. But for ships, especially for ports, cyber attack as a great physical element attack would lead to physical consequences. So if we have a cyber attack, the ship running is in a ground solution or even loss of cargoes. The significant disruption in the operation leads to financial loss also. This diagrammatic chart will reveal the exact scenario of the challenges what we are facing when the security is not properly arranged or planned in the ports and the ships.
All right, Uma.
Suggestions.
Yeah.
Yes, sir.
Is this the last slide?
Yes, sir.
Yes, please.
Let's see some suggestions. By making the effective usage of maritime surveillance is a combination of both various software and hardware modules. The microsatellites, microsatellites, SAR technology, radar satellites, InmaSat, etc. has to be improvised with the updated technologies-based surveillance. Innovative ideas and research development programs has to be carried out periodically so that the information exchange between the onshore and vessels are now becoming a cyber part playing field by the remote satellite connection. More on monitoring systems are increased being used in the maritime industry to help in maintaining the port security planning efficiently. Adapting professional training programs with irrespective of any departments, like providing professional port programs, port and ship maritime security training programs, port security management workshops, certified port executive program, port security and exam, etc. And coming to the last is shippermen. Shippermen are the first frontline person who are subjected to detect the threat in earlier. So, if we're providing the adequate training and the operation knowledge of using the satellite phone and the VHF radio to all the shippermen, we can able to get early and possible collection of threats as soon as be possible.
Yeah. Okay.
Yes.
Yes.
Uma, are you, what's your background? You're from MBA, I noticed,
Yes,
is it?
sir. Yes, sir.
This paper, was it vetted by somebody? Or you're the alone?
I'm alone, sir.
Next time, please have it vetted. Next time, please have it vetted by somebody before you come on a national level conference like this.
Yes.
Right? Both of you are mixing up issues of ISPS and cybersecurity. Both are different subjects, and they are not being handled together as well.
Okay, sir.
But good effort. Good effort.
Thank you, sir.
Any questions, gentlemen?
Yes, sir, there are questions, but because of saving time, we are just sending the question to the participant through email and we will get the answers.
Okay.
Sure.
Yes.
Okay. Thank you very much. I would like to go back to Dr. Sivaswamy. Thank you very much for giving me this opportunity for handling the session one, and all yours, sir.
Thank you very much, Captain Bharadwaj. All 7 papers were presented well. All the participants, they have done their job at their level best. In your busy schedule, you have given your time. We have actually, it was scheduled 1 hour, exceeds more than 1.5 hours. Thank you very much for your kind support, Captain. Thank you. Thank you all the participants.
Thank you. So it's a break now, and then people come back after 10 minutes or so?
Yes, sir. We have a break. Before the break, I myself and on behalf of School of Marine Engineering and Technology, thank you, sir, for your patiently you were listening all the papers and you have given guidance. The way it was conducted was very good, sir. Thank you very much.
Thank you, Dr. Lakshmi. Thank you.
Thank you. All the participants, can now go for lunch, and other participants who are waiting can join for the next session, session 2, on electrical, electronics, control and automation. After 5 minutes, we will be resuming to session 2. I will read out the participants' name for the next session so that they may be ready. The first presentation will be by Arjit Patra. The next paper would be by Ziaur Rahman. Then it is by Arun Kumar Verma. Then it is by Ribidik Kumar. Then it is by Mr. Ganesh Ram. And I request all the participants to be ready after 5 minutes. Our session chair is already available and you would be joining us after 5 minutes. Thank you.
Madam Tangalachmi, I just wanted to check the voice and I want to confirm my clarity.
Yes, sir. Yes, sir.
Yes,
Am I loud and clear?
Yes, sir. Clear.
Thank you. Thank you.
Sir, we will start after 5 minutes, sir.
Fine, madam.
Yes.
Standing by.
Yes, sir. Yes, sir.
They were studying, huh? So he be there. The only going to start in 2 minutes. If you be there, something is required, I will call you. Because without that phone itself, they have checked, they told that it's clear. So I'm going to proceed with that. I will.
Hello. Varun, are you available? Varun?
Yes, ma'am. Yes, ma'am.
Varun, I have sent you that list of papers. Check whether it is available, whether the people with that paper name is available.
Okay.
Yeah. Otherwise, you go by the next papers, right?
Okay.
I have now sent the fresh list. Ziaur Rahman is available. Wasim Asrar is available.
Arjit Patra is also available.
Available. Okay. So we have some 3-4 papers, right? We will go with that, right? We'll start by
12:20. Yes, sir. Welcome back, one and all present. I think the intermission break is over.
Yes, we have started. Yes, Varun.
Yes, ma'am. Welcome back, one and all present. It is my privilege to introduce the session chair of the next session.
Wait, just a moment. Yes, we can.
Ma'am, please. It is my privilege to introduce you the session chair of the second session, Dr. Ma'am, please meet us. Hello, ma'am. Please meet yourself. Dr. N. Deceleration pursued Bachelor's in Electrical and Electronics Engineering, MBA in France, and PhD in Technical Economics of Natural Gas Production. He has experience of around 25 years. He is currently the project director and HRD in charge of National Institute of Ocean Technology. With this, I would like to invite Dr. N. Deceleration to say a few words and start the session. Sir, please. Sir, please. Deceleration, sir.
Session chair is online.
Yes. Are you able to see me?
Yeah, please, few words to the gathering about the electrical electronics automation. Yes, chair.
Yeah. So, good afternoon to you all. At the outset, on behalf of NAO Teacher I would like to congratulate the organizers of the School of Marine Engineering and Technology in bringing out this e-conference on energy, environment, and sustainable engineering, shipping. I thank Dr. Marini Shankar, IAS, Vice Chancellor and Director Dr. Raju Balaji and his colleagues, including Professor Sivasamy, for providing an opportunity to chair this session on electrical electronics and control. As all of us know, 90% of the global trade is through oceans, comprising of a network of 95,000 ships with a GWT of approximately 2 billion tons. Considering the importance of reducing the emissions and creating sustainable shipping, IMO has adopted Goal 13 strategy, we all know, by setting standards and targets for greenhouse gas emission reduction by 50% by 2050. Moreover, the recent regulations on low emission fuels and NCEESS guidance on hybrid battery systems and automation for DP vessels show cases of that is importance for this topic, the present need of this topic in this session. In the Indian per se, we in India have a fleet of 1,400 ships with a capacity of 10 million tons. Understanding the advantages of water transport, the government is improving the ports to reduce the turnaround time and planning to increase the present share of the waterways for domestic transport, from 1% to higher levels. We are also aware that China and US use 24% of the China waterways and US 6% of the waterways for their domestic transport. So this is a very important transition what we have to make nowadays, and I am sure that IMU has an important role in catalyzing this national important transition on clean energy for the ships. So it's very clear that now we have to high time to address the topics including switching to low emission fuels, hybrid power systems and microgrids on ships, silent ships, port security, ballast water treatment, and the use of artificial intelligence, Internet of Things for operational improvement and safety. With respect to this conference, I am given all the papers prior. I see that all the papers have been presented now, and including this session, which you are expecting, this one covers all the topics of strategic importance, which indicates our awareness level and the efforts towards clean transition. I think with these few words, I think if we can move on to the session, and I think the presenters can come ahead and take the stage for presenting their papers. Thank you very much.
Thank you, Dr. Vedachalam. We can start our presentation.
Thank you, sir. I'd like to invite Sri Ajit Patra to present his paper of the second session. Please, sir.
So, good morning, sir, and madam present here too, and good morning, everyone. So, just let me share my screen. So today I'm going to present on the study of simulation of fuzzy compensator for better dynamic response. So basically, if we consider a system, the most important factor of the system is the transfer function. And with the help of this transfer function, we are going to obtain the output response. And the output response is the thing which is the main characteristics of a system. So it is a very important factor to control the system response, and up to till that we are using the either the proportional controller or the proportional integral controller or proportional derivative controller or the idle controller. But it has been seen that the output response to these controllers has various overshoots and undershoots in it. So we want to develop a system that will reduce the transient time and hence the delay time will reduce and will reach to the steady state in a very short time, and hence the nonlinearity of this response will decrease. So as it is, we are considering the fuzzy logic controller. So it is required to know what is fuzzy logic. So fuzzy logic is a form of many valued logic in which the truth variables or variables may be any real number between 0 and 1, but both 0 and 1 are inclusive. A fuzzy logic is based on the observation that people make decisions based on imprecise and non-numerical information. So these models have the capability of recognizing, representing, and manipulating, interpreting, and utilizing data and information that are vague and lack certainty. Now, the reasons behind the non-linearity or this delay in reaching the steady state in the normal controllers is that, say, if we are considering, say, this is the transfer function we are considering here, and we are considering this PI controller here. So the output response that is obtained here is that it has 2 overshoots and 1 undershoot, and it also takes more time to reach to its steady state response. The main reason for it is due to the reason that if we take the characteristic equation, then it is of the 3rd order characteristics, due to which non-linearity in the response arises. So the remedy is the fuzzy logic controller, which we are going to develop using the Mandani method. So this method was proposed by the Eversum Mandani in 1975. So we need to first follow various steps in performing and reach to this response. Firstly, we need to consider the input parameters and set rules for that. Secondly, we need to consider the input parameters and turn their fuzzy logic that is in between 0 and 1. Thirdly, we need to combine these rules and this logic together. Next, And yes, we need to combine this rule strength with the excitation, and similarly with that to logic excitation with the fuzzy logic in between 0 and 1. And hence a surface clause can be obtained after performing all this. So we can demonstrate using this diagram. Say if it is the first input and if it is the second input, then after performing the AND operation, we can see that the rule strength is this, and hence the surface plot obtained is like this. Similarly, in this case, if we perform AND operation, then this is the rule strength, and hence the surface plot obtained is like this. And after combining these two, you obtain a surface plot like this. So the fuzzy logic, so the fuzzy controller we are considering, so that is the same function we are considering as before with the help of the PI integral PI controller. Now this is the fuzzy logic controller we are considering, that the input is the error input, which is the input minus the feedback, and the other one is the derivative of the error. So as we are using a multiplexer here, so it is actually performing the summing purpose. So we can say that it is a modified PI controller. So we have considered here the block diagram for this, that first is the error input, second is the derivative of the error, and this is the controller, and hence it leads to the excitation. So for the best response, we have considered here that the input is in between logic from 0 to 0.2, and it has been divided into low error, medium error, and high error, respectively. Similarly, the derivative of the error has been divided into 3 parts, ranging from logic 0 to 0.8. Similarly, the excitation has also been divided into low, medium, and high, and it is also ranging from 0 to 0.8. These values are often after performing various responses, and we obtain the base feedback for these values. Now we have considered this is the rule strength where we have considered, and it is seen that the excitation is following the derivative of the error input. After performing all this, we obtain this type of surface plot, and if we see the output response, it has been seen that the overshoot is reduced and it steadily reached to steady state within with having less delay time, and hence the transient response is reduced, and hence it reaches to its steady state with a very short interval of time. Moving on to the conclusion that this fuzzy logic controller can be a very much can replace this normal controllers used today, like the PID, PIP, or PD controllers, as it helps to reach the steady state having less transient time, and having less delay time, and it can be a good replacement and can be used in determining the dynamic response of a system. Thank you.
Thank you for your presentation. We have one question from the presenters. It is from Mr. Prabhu. Which equipment on board has potential to be upgraded to fuzzy control than PID control?
Yes, we can consider this. If we can consider the boiler, then boiler is a very important part in the ships, which can be upgraded with this response to control the steady state response of the of that system present there.
Okay.
Okay, Mr. Puneet. Yes. Your presentation was nice and it was very informative, of course. And first of all, you should focus your presentation or your content applied to a specific area. For example, you told that this can be applied for an industrial boiler or a power system or a marine boiler. So in addition to that, we have to see various other areas, including the dynamic position, ship propulsion, and other areas and all, and we have to see that where it can be applied. Now you can take some example cases, okay, and you can apply that and see for which cases which is better. Of course, you are telling that PID, we're comparing PID with this thing, your fuzzy logic and all these things. Each has its own merits and advantages and disadvantages. We can classify them and you can show which area is more better. That could bring in more insight on what you are trying to say. And the application to a typical, DP system could be more important. For example, other kinds of, things are there. Machine learning things are now emerging. For example, if you say the model-based control, you need to subject the device, or subject the ship to carry out, position variations and capture the response from that, force response characteristics. And from that also you can bring out. So all these things you can bring out and you can consider this for your future presentations and studies. Good luck.
Thank you, sir.
Thank you, sir. Now move on to the next presentation.
Yeah.
For the next presentation, I would like to invite Shri Ziaur Rahman to present the paper. Please.
Yeah. Am I audible?
Yes, very clear.
Yes. Good afternoon, one and all present here. I'm Ziaur Rahman, final year student of Naval Architecture and Ocean Engineering from Indian Maritime University, Vizag campus. I would like to thank our VC, Malini ma'am, for providing this opportunity, and I would like to thank all the people, all the hosts, all the organizing faculty for providing this opportunity for me to present my paper. I would like to extend my thanks to my guide, Sri US Ramesh sir, who has been very helpful all along in developing this, and also I would like to thank the convener right now, Dr. Vedishalam sir. I would like to present my screen now. I will be using a video that I have created of my model to explain the working of the model. This is an IoT automation control model, control and monitoring model, a proof of concept to describe and to prove the actual working of the IoT in the maritime sector. We have implemented it on a twin screw boat using ESP32 module. It is a Wi-Fi connectivity module. It provides connectivity towards. It provides it acts as an access point actually. Initially, when we configure it, it connects to the Wi-Fi and gives us ability to talk to the device over internet. It gives us a supreme ability to exercise control from almost anywhere in the world just by connecting it to an internet connection. And then here we can see we have the manual control using laptop interface. Also, we have implemented it using Google Assistant, providing it the voice control ability. Here we see ahead, astern, port, and starboard actions being carried out at the maximum RPM. Left side of the computer is the RPM slider. We have implemented it using the Adafruit IO platform, cloud database platform available for IoT implementation. We have the speed and the direction control here. Now I would like to present the video demonstrating the voice control. Here we see the voice command being given to Google Assistant, and the response time is roughly around a couple of seconds, a lot of times, but then most of the time it is quite fast once the AI gets trained properly for receiving specific commands. And it also has voice recognition so that other voice interferences are eliminated, provided by the Google itself. This is a very preliminary model of describing how we can use IoT in maritime field. We also have a lot of different implementations of this. Recently, during this COVID quarantine time, we have improved the model by providing it with the ability to receive remote updates and remote Wi-Fi credentials. Further, we are working on a new protocol called ESP32 Now protocol, which enables us to create a mesh network of a lot of different access points in a ship, which will be talking to one single access point, which will be connected to the external internet, which will definitely eliminate a lot of cabling in the ships, and then it will provide very quick and very fast communication without any hassle and completely wireless, and it is almost instantaneous. We are right now working on it. Also, the over-the-air update and over-the-air Wi-Fi credential update technology that recently we put into the R model, it is very fascinating. We'll be able to, we can just update all the modules connected to the internet without actually using any cable connection, just over the wire. Just when a command is initiated, a reset command, the Wi-Fi modules, the node ESP nodes act as access points, providing us a hotspot to connect to, where we can connect our devices using WPA2 authentication, and then we can update the code, we can update the Wi-Fi credentials if they have changed, and we can put in security patches. There are a lot of issues in these, according to the recent IoT issues and IEEE conferences on IoT. A lot of different issues with the security and all these things are right now being taken up. Whereas as far as I understand, no device and no system connected to internet is completely hack-proof. This IoT implementation will definitely require a lot of continuous monitoring and continuous offensive and defensive security measures to keep it safe from all sort of external intrusions. Further, I would like to talk about the container ships that can use this technology to monitor container cargoes, which is what recently a company is doing called Maritime. It is using IoT to monitor the container cargo and provide the container cargo information to the owners of the cargo, which is an excellent approach. Like just on a mobile phone sitting in a remote place, connected to internet, anybody, the owner will be able to very easily have the complete idea of all the state variables that are affecting his or her cargo and the place and the handling of the cargo completely and at any point of time. Also, the state variables of the ships can have a lot of different fluids, mechanical, thermodynamic processes going on. All the state variables can be very easily monitored and sent to a central vista system, which can be very helpful in further development. Also, these data loggings can be used for machine learning, for implementing and training machine learning models, which are of very important value in near future. I would like to end my presentation. Thank you.
Thank you, Mr. Rahman. That's a very promising presentation. I'd like to hand over to Salam sir for any comment.
Mr. Rahman.
Yes, sir.
Yeah, so really a nice presentation, and it's a good effort made by you and your guide, Dr. U.S. Ramesh. Congrats. And just I have two questions from you. One,
please, sir.
Have you ever looked into the possible latency? I mean the delay time.
Yes, sir.
When it is really applied to commercial ships.
I haven't worked on the application of it onto the real ships, but whereas right now using a 2G network, I degraded the network to 2G speeds, and then I tested it on various platforms. The best results I got was using Uplink and Taskmota applications. The response was almost instantaneous, whereas the voice control is a little bit slow, but whereas the direct interface control using device is excellent, and it is instantaneous, sir.
Yes, whatever you are telling, it is applicable for coastal networks where the 2G or 3G is available readily. But in case of offshore, when it is powered by networks such as Inmarsat and all, the response time is very important. So what I recommend you is that you can go into the General Electric website, the company GE website. You can see something called VISOR, VISOR. In this, yes, in this, what they do is that all the entire power and control systems, whatever there in the ship, are reported in real time to their GE control center, to the centralized control center. And the control center can monitor and they can modify any program and download or upload any program from their control station to any ship across the globe.
Yes, sir.
So
Thank you,
this
sir.
is being operating in real time, and if you read this, it will help you to improve your knowledge.
Thank you very much, sir. Thank you very much, sir.
So now you can answer any questions raised by the audience.
Yeah, there is one question from audience. ESP8266 is not capable enough to host an AI application. You have mentioned about AI implementation. How do you propose to do that?
Ma'am, ESP82, we are not talking about ESP8266, ma'am. We are talking about ESP32, which is also not capable of implementing AI programs. It is just an access point for the data to flow from internet to the specific ship. It is just an access point which acts and it implements basic logics. It's not capable of implementing tensors. So we will have to use onboard systems that are capable of analyzing and outputting AI applications that are capable of learning machine learning applications that those systems are very different from what we are talking. We are talking of very precise and very limited control and monitoring of the state variables, which are just data input, data reception and data transmission. Whereas the AI thing, it is completely hosted on cloud platforms or on the onboard systems that are capable of doing it.
Yes, thank you. I hope Anirban Batterjee's question is answered. I have my own question. You said that there are many variables, state variables available, right? Though you are modeling as you are making a model using state variables, how many sensors you actually use in a commercial ship? And how do you connect to your model?
Ma'am, very precisely speaking, we haven't implemented it on a large scale as a ship right now. We are testing its latency, its connectivity, and its preliminary functioning right now. Whereas there is a lot of research going on implementing it with the sensors, and then there is also a lot of regulatory issues as well, and also the connectivity part of it. In the offshore high seas, we need connectivity, which we might probably get using the latest endeavor of Elon Musk, the Starlink technology. We'll be able to have very good connectivity there, and then we'll be able to transmit a lot of data and receive a lot of data. And almost any sensor that is electrically or electronically controlled or operated can be the feedback from the sensor can be taken and sent to the central system for storage, analysis, and response.
Thank you.
You're welcome, ma'am.
Thank you. A very promising session from Mr. Rahman. I would like to gladly invite for the next paper, Sri Ritvik Kumar, to present his paper on modification in braking technology of ships. Or anyone is anyone.
Am I audible?
Yeah.
Yeah. A very warm afternoon to one and all present here. I am Cadet Shauryan Karmakar.
I am Cadet Ritvik Kumar.
I am Cadet Mamika Star.
And together we are Team Literal Minds. Currently, we are the students of third semester pursuing our BTech Marine Engineering from Indian Maritime University, Kolkata campus. And we feel privileged to be presenting our work in front of the esteemed group of people present here. It was reported that approximately 21,325 ships involved in accidents, leading to 25,000 deaths and 8,000 injuries in the period 2007 to 2020. Looking back at the analysis, we find that collisions contribute to 36% of the mishaps, while contact doing 17% of the damage. Summing them up, we get a huge figure of 53%. So if we focus on avoiding collisions and contact, we would prevent more than half of maritime disasters. While going through data, we find that 20 to 25% of vessels involved in maritime accidents are cargo vessels. Out of 15,103 ships involved in accidents during 2007 to 2020, 2,848 were cargo vessels, as can be seen in the graph 1. So the question here lies is, what is the problem? On an average, the length of cargo ship is 200 to 300 meters and the average speed is 20 to 30 knots. And the average time to bring such a ship to rest is about 25 to 30 minutes. This period is more than enough for ships to collide with other ships, periphery of ports, or even icebergs. And here the major problem occurs.
To cater to the problems as stated above, all we need to do is focus on reducing the collisions and contact type accidents on cargo containers. So our idea revolves around this very point. So let us look at the principle involved in the deceleration. When we look into the functioning of a ship, the ships are brought to rest with the help of propellers and varying function of engine. There are specifically two types of propellers, fixed pitch and controllable pitch. The primary aim of stopping any moving object is to increase the drag force experienced by the body. This can be done primarily in two ways: increasing the wetted surface area of ship, or by decreasing the magnitude or change the direction of thrust on ship. So our idea focuses on executing it both the ways. So as a solution to the emergency deceleration problems, we give you the ECDS and EBP. ECDS, Emergency Cargo Drop Stop. This system suggests some part of the cargoes on ship likely to be 10 to 15% to be kept in specially designed boxes that would be ferromagnetic in nature and with the ability to be water repellent. The boxes would be kept on a sliding platform in the hold, hanged with ropes operated on free fall or hydraulic power system. The boxes would be designed in such a way that when hanged, these boxes would open into two halves, making 45-degree angle between them. This would increase the exposed area and would also allow, and when allowed to touch the seabed, when the length is approachable, could act as a pool type anchor. So then this system also suggests the incorporation of a thick electromagnetic strips running across the hull below the waterline. The strip will activate when the ECDS containers are dropped off through strings or any rope in the seawater. Precisely, it will activate as soon as the ECDS system starts acting. When situation suggests a condition of extreme urgency to decelerate the ship, the boxes with the platforms would slide outwards the hull, depicting fin-like structures, and the platform would then fall and stick to the hull, and the boxes would be dropped. As soon as the boxes are made to drop into the water, the electromagnets running across the hull will be activated, and the boxes would be made to stick to electromagnetic strips. The boxes would enhance the amount of areas exposed to the water, exponentially adding up the drag force, ultimately increasing the resistive force. So when the ship is lowered as per the need, the electromagnets will be deactivated and the cargoes will be heaved up thereafter. The specially designed ECDS boxes can be dropped under free fall to the seabed when the seabed is at an approachable distance and thus can act as anchors. This ECDS system would come into function with the help of gearbox. Installation of this should be near the tail shaft of the propeller as per our idea, which will be designed in such a way that the translational motion of the platform with the ECDS container starts as soon as the propeller's RPM is set for lowering in the case of fixed pitch, or when the blades start orienting themselves in the parallel direction in case of controllable pitch. Now Shorin will take over.
Coming to our next idea, that is the EBP, emergency braking propellers. So the second part of a solution suggests installation of add-on propellers to the already existing propellers, but these propellers will be placed in the front region of the ships. These will completely fit into the ship's side walls, maintaining the streamlined shape of ships, and will only come out when EBP mechanism is initiated. They will then drop into sea to the level of stern propeller and will start to operate in a direction so as to oppose the motion of ship. This will increase the resistance offered to the ship's motion. The stern propeller's RPM will be then reduced and direction reversed so that it reaches no thrust position. The speed of stern propeller will be then increased in opposite direction so that it matches the speed of EBP and both the propellers end up having the same RPM. Thus, the stability of the ship is maintained. After successful deceleration, these EVP can be again retracted back to their original position. A ship's hull design will be altered so as to provide space for a compartment which can accommodate a propeller on each side, along with the hydraulic arm which will open up when EVP is initiated. We are further deliberating upon the use of EVP as add-on propellers for steering ships in regions involving sharp turns. This will increase the overall maneuverability of the ship. We are also concentrating on the financial part of the entire project. Efforts are being put into making these designs as economical as possible. The mechanism for the simultaneous use of ECDS and EVP, which offers a benefit of further reduction of braking time, which can prove to be of immense importance when faced with crucial situations of life and death, is also a point of discussion.
So let's look at some of the advantages. First is avoid collision by fast deceleration. Second, these ideas, if implemented, can prove to be crucial in life-threatening situations. Reduce number of collisions, implying greater profits for the owners. Effective even in extreme weather conditions. Quick and effective braking system with low initiation times, and it also gives the option of using one braking method at a time or combining them according to the situation's demand. So that's all for.
Thank you.
Okay, Mr. Arthur and team, really it's a good presentation. Whatever ideas you have presented on both the ideas regarding the braking or decelerating the ship during an emergency is really nice and appreciable. I want to know, one question is that whether this has been implemented in any ship, whether part of the idea or something like that?
No, sir. This whole idea has not yet been initiated or applied to any part of the ships as of now. And that's why we came up with this, because as we can see that braking is one of the major causes. The slow braking is one of the major causes which causes a lot of accidents.
Yes, fine. So as it being the first of its kind you are proposing, claiming, what I propose is that you check out the feasibility of the concept, because from the engineering, the concept is fine. Okay, so this is fine, engineering concept, and how far it is going to be applied in practice. What I recommend you to do is a numerical model to estimate the wetted surface area requirements. Okay, in case of kind of drop weights kind of thing, and in case of thrusters, propellers rotating in the reverse direction to contain the speed and to bring it to a halt, you estimate what is the speed requirements. Basically, you do a numerical modeling with ANSYS or something like that, and you come out with some numbers so that we can see the economic feasibility of implementation. Second thing is that dropping these weights have impact on the stability of the ship. You also have an assessment on this one. The third thing is that you are talking about the electromagnets which are going to be on the bottom of the ship hull, and those weights, the systems which are dropped can be attracted like that you are telling. You also estimate through modeling how much would be the energy requirement. For example, what is the power requirement for holding the weights? So like that you can estimate and you can come out with numbers so that you can compare different technologies and identify which is the feasible one. Okay, this will help to go in further into this topic and refine your ideas. Okay.
Yes,
okay, thank you, sir.
Appreciate it. Thank you, sir.
Yeah. Any other question from the audience? We can.
No questions, sir.
So yes, go on with our paper. For the next paper, I would happily like to invite Sri V. Ganesh Ram sir to present his paper on energy storage system.
Who is presenting?
Sir, it is me, Tangalakshmi, presenting the paper, sir.
Fine, madam. Good luck.
Thank you, sir. So before proceeding to this paper, it's only a review paper. I am just projecting this in order to make why this energy storage system is so important, especially for maritime sector. This is just a review of a few papers, only a few different areas where it has been applied. Those three papers alone I am projecting in my presentation. So we all know that the electric propulsion is very common in all onboard systems, and it is very popular also. Previously, it was only a direct-driven propulsion system. Even some vessels, even now, they are adapting direct-driven propulsion system. But we know why we have to go for electric propulsion. So nowadays, the direct-driven propulsion systems are not that popular. When we are coming to electric propulsion system, we do have AC-based system and DC-based system. AC-based power systems are dominating, and DC-based systems are now getting popular because of the advent of power electronic converters and the power electronic based breakers. They are capable of breaking heavy DC currents nowadays. So the DC based system, it is very common to utilize the possibility to allow diesel engines to adapt to the change in speed requirements with reference to the loading, and also the major objective is being the reduction of fuel consumption. That way, this flexibility cannot be directly used in pure AC based system. So in an upcoming alternative to reduce fuel consumption, especially for AC based system, is to introduce onboard energy storages. So when we are going for AC system, we do have onboard energy storage system as well. So onboard electrical energy storage for the purpose of reducing the fuel consumption in vehicles such as cars, buses, and any locomotive is very common. The maritime sector is also following the same trend nowadays. So new builds and retrofits are now being equipped with battery energy storage as supplement to diesel energy system, diesel generator sets. We can give some few examples like plug-in vehicles. They are charging in harbor, similar to the ground-based plug-in hybrids. There are an increased number of vehicles or vessels sailing with batteries, which will be the only power sourcing medium. So knowing about energy storage system, especially to with respect to the shipping industry, is very, very important. So when we are talking about energy storage system, it is not the only system used in the ship. We do have parallel systems with which your ship is operating, right? But when we are managing the energy, it is managed by how effectively we are managing the battery system. So there are some issues that is still available in energy storage system. The thermal transport and thermal management in batteries are very important issues, which is having direct impact on the performance and the safety and the reliability of the energy conversion and storage behavior. If these batteries are not kept within optimum operating limits, then definitely it will be impacting on the performance. For most batteries, the temperature should be kept within 30 degrees Celsius. Probably it is ranging between 5 and 30 degrees Celsius. And it is preferred if the temperature variation between the cell in a pack is kept within 5 degrees Celsius. It is also known that the battery life is curtailed if this temperature is increasing, say for example, if it is beyond 40 degrees Celsius. Similarly, extreme cold climates like a below freezing point may limit the amount of current that can be drawn from the battery. So there are some qualities through which the energy storage system is governed. We do have state of functions. The factors affecting the capacity, energy, and power output of battery are correlated and depend on the particular technology being used. To operate any electrical vehicle, even the ship propulsion, the battery management system, which is referred by BMS, should be able to inform about the power and energy status of the battery. These state functions are used, and most common ones are the state of function, state of charge, and state of health. Such functions operate on different time scale. State of functions represent the power capability, and they operate on seconds on millisecond basis, while SOC is on minute scale and SOH is on monthly or yearly basis. The SOF refers to the capability to fulfill the demand, especially the power requirement at a particular time. The SOF can be estimated in different ways and is strongly dependent on SOC and SOH and mostly on the temperature. The accuracy of measurements of voltage, current and temperature is hence important for SOF prediction. State of charge is defined as the ratio of available capacity and the maximum available charge that can be stored in a battery. SOC is given as the ratio of Q of T and Qn. A fully charged battery will be having a SOC of 1 or 100%, while a fully discharged battery will be having it as 0 or 0%. The rated capacity or the capacity at the beginning of life is commonly used as the reference value. So SOC is the key parameter to control the electrical vehicle or the propulsion of the ship to secure the power responses due to changes in the operating condition. The factors affecting the SOC significantly on a short time basis are the temperature and C rate. C rate is another important parameter on which we are validating the quality or the performance of the battery. It is often expressed as C rate in order to normalize against battery capacity, which is very different between the battery capacities. Like usually the battery rating is given in ampere hours. A C rate is a measure of rate at which the battery is discharged relative to its maximum capacity. For example, if we say 1 C rate, it refers to the discharge current, which is discharging the entire battery within 1 hour. If it is 100 amperes hours, that is, if the capacity of the battery is rated in 100 amperes hours, then 1 C refers to the discharge of current of 100 amperes. Likewise, 5 C refers to 500 amperes and 0.5 or 1/2 C refers to 50 amperes. However, there is no simple method available for accurately estimating the state of charge. It is related to the properties of the active electrode materials, and different active materials behave differently. Though we say a lithium battery, lithium is having many combinations, so accordingly this would be differing. For lithium ion cell, 100% SOC refers to the state where all cyclable lithium ions are inserted only in the negative electrode material, and 0% equally refers to all the cyclable lithium deposited on only the positive electrode. So for cells based on lithium cobalt oxide, the amount of cyclable lithium is less than the total amount of lithium in the active material due to the stability issues of lithium structure. Sometimes there is another variable given, which is the depth of discharge. It is used to describe how deeply the battery has been discharged. In most of the cases, this DOD is also related to SOC, and it is given by 100 minus SOC in percentage. Let us now see what is state of health. The state of health is an indicator of remaining battery capacity compared to the capacity of BOL. The aging processes which lower the SOH start as soon as the cells are assembled. As the battery ages, the SOC will decrease until the battery can no longer fulfill the requested performance and end of life has been reached. Means we have to maintain the battery life in order to maintain the performance of the entire propulsion. So SOH is not a physical quantity, but it depends on parameters like number of charge discharge cycle, capacity and power fade, and internal resistance. The aging process of battery is complex and depends on the involved mechanism. The aging depends on the vehicle usage, battery and cell design. Temperature, SOC range, energy and power condition, and time are other essential parameters. So why I am telling this is that we do have energy storage system on vessels. So for maintaining the energy storage system comfortably, for better performance of the entire propulsion, we need to know about these parameters. So the next thing which is affecting the battery performance and indirectly have impact on the performance of the vessel is the temperature. The generation of heat in the battery will be deteriorating the performance. So as you could see from this diagram, any heat developed will be increasing the exothermic reaction rate, which will be increasing the auto-oxidation rate, which will again release the heat. This effect is cumulative and there will be a process called thermal runaway. So the temperature is very, very important parameter through which the battery life is judged. You could see a few of the graphs related to battery. So this graph is showing the battery voltage with respect to time, and you could see that there are various ranges through which the battery is operated. And as deliberated in the previous slide, the range may be between 5 degree to 30 degrees Celsius. And when we are exceeding 40 degrees Celsius, then the battery life is very much affected. So you could see from this graph, like when you have 40 degrees Celsius, this is going to be the graph, and the battery life or the battery capacity will not be used to its fullest ampere hour rating. And see that this is 0 degrees Celsius. And when we are going through some climatic changes, or when we are moving to such regions where the temperature is below 0 degrees Celsius, then also the battery life is affected. And the power limit during discharge and the desired operating temperature is shown in this graph. See that this graph is with respect to the operating temperature. Again, you could see that between 15 degrees Celsius and 35 degrees Celsius, the battery can be operated to its fullest rating. Otherwise, below this 15 degrees Celsius, then the electrochemistry becomes sluggish, and after 35 degrees, then there will be a degradation in the quality of battery. So batteries are affected by the environment they are operating in, that is the temperature and the humidity. The temperature affects the operation of electrochemical system, round trip efficiency, charge acceptance, power and energy capability. Also, it affects the reliability, life and life cycle cost. If a battery is too hot or too cold, the battery will behave quite differently than at normal and designed operating specification. So we do have maritime vessels coming in different size and structure, are probably in different shapes. They may be built for short and long distance voyages, and they can be used for fundamental different purposes with changing, which will be changing criticality, right? Because when a ship is moving from one place to other, it will be going through the climatic changes also. Accordingly, the temperature variation will be there. As per that, we have to go for the battery management system. The consequence is that there is a variety of power system topologies found on board maritime vessels. Some vessels will be carrying large electric power plants with multiple diesel engine generators supplying the onboard activities and multiple propellers and thrusters, while others are equipped with propulsion system directly driven by diesel engines that are at the same time powers shaft generators to provide the necessary onboard electrical power. So the variation in electric power demand is varying. A vessel on a long distance voyage will usually have much more constant and predictable load demand than a dynamic positioning offshore supply vessel trying to stay at a fixed position, fighting against varying environmental forces from wind, current and waves. So when we are designing a ship which is having its travel time minimum, or which will be covering only a minimum distance, then there will be these dynamic conditions existing frequently. So these transient conditions should be taken care to have a good battery life, which will be impacting on the performance of the vessel. So there are some papers which are researching on this energy management system. One author has taken this kind of model, which would be having diesel engines, and they do have two battery storage system as shown by this figure. Choosing the optimal type and size of battery storage for a given hybrid maritime vessel is really challenging. Investment cost, fuel saving, and energy storage expected lifetime will be affected by these choices. Furthermore, the optimum choices depend on the operation profile of the vessel as well as safety related constraints in different vessel mode operation. So this particular author is not focusing only on the type and the size of the energy storage system, but also he has taken care of the investment cost and the operating profile of a particular vessel, also the safety related constraint. When we are using energy storage system, safety is another aspect that has to be considered. Right, so everything has to be taken care for a better, not only for the better battery life, for the better performance of any vessel. So in addition, the optimum power management strategy will be more dependent as well as dependent on type and size of onboard energy storage. So this particular author, he has suggested different modes of operation along with this energy management system. He has given mode 0 to mode 5 like that. So each and every mode, he had some specification. Whether if this vessel is of this type, this mode can be preferred. Like that, he has given some suggestion. Like in some modes, it is fully dependent on the energy storage system without any backup. In some modes, there will be some spinning reserve. In addition to energy management system, or in addition to battery backup, we have to have a few diesel generator sets running. Right. So accordingly, he has taken all the parameters into account, and he has suggested on the type and size of the onboard energy storage. Finally, the total system has to fulfill certain safety related rules and regulation that typically favor the use of storage and set some constraint to the size and utilization of the storage. So if we have the more number of energy storage, it will be occupying more space. Automatically, the vessel size or the vessel has to give more space for this energy storage system. So this decides the size of the vessel also. And there is one other researcher who is researching on unmanned underwater vehicles, which is UUV, which is widely used for survey and mining of natural resources, especially available in the region of underwater and seabed. In underwater, vision and depth perception will be poor. Thus, navigating and maneuvering a remotely operated vehicle, ROV, will not be very easy. Usually, the power connection will be tangled and there will be frequent disconnection. So, in order to ensure power, we have to rely on energy storage system. So, in the event of ROV losing power from its connecting wires, an autonomous underwater vehicle, AUV power failure, an emergency power system will be needed to power the critical equipment. At least some critical equipment of ROV must be powered. So we need to have an energy storage system. So this author is projecting on how important the energy storage system is in the case of your UUV. And he has modeled, he has proposed an emergency power system using lithium iron phosphate battery stack power system. And he has analyzed the battery management system, and the efficiency is weighed based on the SOC estimation. And there is one other author who is talking about hybrid power which is used for vessels, like how fuel cell is parallelly used with lithium battery, then how the cost and the energy is being governed. So the hybridization of proton exchange membrane fuel cells, that is PEMFC, with the lithium batteries recharged from shore generated electrical power may potentially offer desirable emission performance. So we are talking about pollution free shipping nowadays. So we have to be concerned about the emission level also. So if we adapt this kind of hybrid system, then we can match the standards for emission, especially for coastal ship with access to H2 replenishing and battery charging infrastructure. If we do have such a kind of infrastructure to charge the battery and to replenish H2, then we can adapt this kind of fuel cells. So he is using this kind of a model. This particular author is using this kind of a model, which is fuel cell plus battery power. This is the model he has given. See that here you have ample of scope for using power electronic converters. So these power electronic converters will be helpful in power management, and also the switching losses can be minimized here, so that there will not be any time lag. And the battery model what he has chosen as a whole for the battery pack is this, and this can be equivalently considered like this, and the SOC versus operating circuit open circuit voltage is given by this for the system what he has modeled. So the fuel cell is generally coupled with the hybrid energy storage system in order to improve the dynamic performance of the system. Therefore, the sizing of this hybrid energy storage and the design of energy management system is very, very important, and it is the present research area. So he has used a support vector model for frequency control, and he has proposed this EMS based on this frequency control. And he is keen on the sizing of this HESS, and he has proposed a mathematical model, and through his experiment, this kind of system is quite promising. And this is the typical EMF structure for the fuel cell and ESS, energy storage hybrid power system. There is a two different control he has taken. He is using a support vector model here. One is the high level control, which comprises of the energy management system, SOC management, power allocation, and equipment protection. The low level control takes care of this droop control. It is separately for fuel cell and ESS, and it will be connected here simultaneously, so that by the algorithm what the author has suggested, you could perform both high level and low level control. So what I am conveying to the audience is that energy storage system is equally gaining importance as your modern ship propulsion systems. There are places where energy storage system is important. It is serving many purposes, like we are going for clean energy. Because of this, we are controlling the pollution. So as per the guidelines given by the shipping industry, if we prefer energy storage system in addition to the other modern system, then we could have better performance of ships, vessels, and we can also model this with a minimum cost if we adapt some algorithm or some new methods. So this is all about my inference from the papers what I have studied. Thank you, sir.
Yes, madam. Really, it's a very good thought-provoking presentation. It's really eye-opener to many of the people, because now power system, energy storage, battery-based energy storage is now emerging. So really, it is very important, the need of the day now. And you must be knowing, very recently, IMO has approved for use of lithium batteries for use in dynamic positioning vessels.
Yes.
Mainly for in view of the energy efficiency and the reliability and the safety also. For all these things, it has been done. So now, this being an emerging area, I think now IMO has to take a lead on this. So for this, what I could recommend is that now having all these basics, what you can try is that you can create a hydrodynamic model of a ship. For example, say service vessel. For example, as you were telling, long range vessels have no much impact on this kind of energy storage, because the load pattern remains same throughout the journey.
Yes.
Oh, in case of service vessels where maneuvering will be done frequently and during DP, when these changes, what you try to do is that you try to make a model with hydrodynamic forces, all these things acting on this thing, and you propose a battery solution to that, and you find out what is the techno-economic solution for a particular service vessel operating in a particular geography. Okay, what kind of temperature cycle is undergoing and what kind of stabilization temperature we have to maintain there. And then what is the amount of charge discharge cycles, all will lead to your return of investment. That kind of model you can do, and you can include the disposal cost also, because lithium as such, it is not a normal thing, it is high level of pollutant.
Yes,
so you have to consider that also. So lifetime costs you have to consider. And IMO has considered this because of reliability also. For example, when the service vessel is operated, for example, outage of the particular generator set will lead to loss. So this particular battery could lead to support a fail-safe situation, so that during emergency, this could be called for. So all these things, these are advantages. So what you can analyze the case by considering all these concepts, and you can propose a solution for different type of chemistries. For example, lithium have many kinds of chemistries, because some chemistry have fast charging and some chemistries are slow charging. Cost wise, it is different, and life cycle, it is CDC, it is different. So you take into all these things and you give a solution for this. So that could reach the people more, and it will give the confidence, because normally presently, if you take in Norway, many of the ferries are operated using these batteries, because once they are closer to the port, in the port, they use the shore power to manage this one. Once it is ferrying, it will mainly use batteries and rarely use the generator sets, or they will use a combination of these two to achieve this performance. So it's kind of green shipping. So certainly with our, Sagarmala project coming in, and more of the inland waterways are going to be powered, more of maneuvering, speed reduction, speed changes are going to be the responsible requirement for the vessels. No, at that time your work will be able to support, and for the government policies also your output will be of much help actually. So I think good, congratulations. So I think you can answer to some other question if people are interested in.
There is a question. Reliability of machineries is a concern. As equipment becomes complex, reliability comes down, right? Actually, I could not understand the question. Machineries is a concern as equipment becomes complex. Yeah, that's why when we are having some new equipment on place, the existing one, we have to manage it, we have to design it properly so that it becomes reliable. So when we are designing the system and when we are adding something new, then we have to arrive at a new policy that is involving the new one. We have to enhance the reliability. That's what I am understanding. Up to my understanding, I am answering.
You see, maybe if I can answer your question.
Yes, sir.
This thing, because we are an NAOT are now working on a manned submersible, which is capable of going up to 6,000 meter water depth, which is being powered by lithium polymer batteries of pressure compensated nature. We can take pressure up to 600 bar and its capacity is 100 kilowatt hour. From this experience, what we learned is that the architecture in which how we place these batteries are very important, and what kind of protection systems which we give is also primarily important. And using all these things, we will be knowing the failure rate of these batteries, because selecting a lithium polymer battery is very important nowadays, because there are extra OA and Z companies in the market, as well as very reputed companies capable of supplying to strategic applications are also in place. So selection of the quality of the battery decides everything. So once this is done, what is the protection schematic is there? How well it is protected from thermal runaway, from overload, and all these things, it has to be seen. Once it is done, it is going to be the safest. We recommend the people to read, our listeners or audience to read. There is a separate article published by Boeing, because Boeing once faced a problem with the Dreamliner, because of the lithium battery failure. Many of the flights were drowned, were not stopped from operating. So from that perspective, they can learn. And what is the moral of the story? What they have given is that application practices are very important. More than the reliability, we should be able to tolerate a failure.
Yes.
That is more important, because failure should not percolate. So once this is done, it may not be available, but it should not lead to an accident. So this kind of things you have to, with the user, the people can read upon to improve the confidence level of using a lithium battery.
Okay. So thank you, sir. I'll take all your inputs and I'll try to work on the way you have suggested. Thank you very much, sir. Thank you for the input and feedback.
Fine.
Last paper, I would like to again invite Dr. S. Thangalakshmi ma'am for the next paper.
My next paper for presentation is optimizing the size and allocation for distributed generation with the immune algorithm. This is nothing to do with the shipping industry. It is the thing what I am talking is pure electrical, like it is for a distribution grid. Suppose if we have a marine distribution system, same kind of nowadays we do have solar equipped, wind equipped ships. If there is a scope for adapting this kind of system, this would be helpful. Otherwise, it's a pure electrical paper. This is having some research. And some simulation results are involved. I could able to get these results with the help of my students. Distributed. It's not presented?
No.
Yeah. Just a moment.
Yes, ma'am. Please come.
Is this visible now? Yeah.
Yes, ma'am. Yes.
So let me present the title again. This is about optimizing the size and allocation for distributed generation with immune algorithm. Distributed generation generally refers to small-scale electric power generators that produce electricity at a site close to consumers. And some cases, it is very tedious to connect the power and substation through the normal transmission line. So such places also we are relying on distributed generation. So their power rating will be ranging from 1 kilowatt to 50 kilowatts. They will be usually connected to the distribution grid. The objective of this paper is to identify the actual location and size of DG units using immune algorithm and to improve the voltage profile along with reduction in power losses in a balanced radial distribution systems. Like here, when we are talking about distributed generation, it may be a solar power cell or a wind power, or it may be a hybrid of both these or any other generators which is generating power of minimum capacity, which could able to serve a local community. Right? Actually, the grid will be there and their voltage will be normalized. And when we are feeding a DG suddenly into the grid, will definitely create some fluctuation, especially when we are talking about the line. The voltage stability is very, very important. So when we are suddenly adding or removing something from the line will definitely affect the voltage stability. So we are in the meantime of connecting the DGs to the line for serving the community, we have to be careful enough that the voltage stability is not affected. So the main aim of this paper is to improve the voltage profile. There are many methods given in literature for improving the voltage profile, especially for DG platform. Along with power reduction, we are giving a new proposal using immune algorithm. Means the time of settlement will be very minimum and the power losses are not much with the suggested algorithm. So these are the objective. With this objective, let me proceed. So I am just taking a IEEE 34 bus radial distribution system. Usually we will be going for a radial system and radial interconnected system. This is just for testing purpose. So I am just taking a standard IEEE 34 bus radial distribution system. In order to have a visualization to the audience, I'm just showing this figure. This is not the one what we have used for our experimentation or simulation. See that you have two different wind generators, each generating 750 kilowatts, and you have a solar cell with a 250 kilowatts capacity, and there is an energy storage system here again, and you have an island interconnection device here, and here you have a normal diesel generator set. So this is a typical topology of a distributed generation sources added to IEEE 34 bus network. Actually, we have labeled from 1 to 34, but in this they have different labels. So this is to show how it will be looking, right? This we are not taking for experimentation. And our system of consideration will be having 34 buses, one source, and there are 33 loads. The rating of the load, the real power load is 1568 kilowatts and 743 kVAR is the reactive power load. And the source is capable of generating at 69 kilovolts. And the bus data we are taking for this system from the available literature. There are 33 buses. The load configuration with reference to each bus is displayed here. And this will be given as the input while writing the coding. And there are line data like between two buses, there will be a distribution line. So the quality, the characteristics of the line, which is given by the resistance and the reactance, is shown here. Right. And let us now talk about the immune algorithm. This is another new population-based optimization method. And there are many such algorithms available. Already genetic algorithm is in place. Artificial bee colony algorithm is one such algorithm. And we have ant colony algorithm also. There are many heuristic algorithms available. And we are proposing an immune algorithm. It is inspired by cloning the principle of human body immune system. So the advantage of this algorithm is that the population size keeps on changing, means it is dynamic and it is determined by the fitness values of the population. So this is the flow chart of the immune algorithm. First, we are inputting the antigen coding. So we will describe about this in the subsequent slides. and then we are initializing the antibody production. Then we are computing the affinity, and the control of antibody generation is done as a second step. And in the subsequent steps, then we are checking for the criteria. Like here, the criteria will be whether the required voltage has been reached, whether the voltage is within the limit or the power loss is within the limit. So after checking for those criteria, if the criteria is met, then it is stopped. The program is stopped. That is, the number of iteration has been over, and we have already found which kind of DG or which place it has to be added is found. Otherwise, we are again looping into the same steps. So let us now describe the flowchart. In input antigen coding, the input data are seen as antigens that include representations of objective. That is, our objective is to maintain the voltage stability. Of course, the constraints will be what will be the minimum per unit voltage, what will be the maximum per unit voltage, likewise what may be the maximum power loss, like that. And in the second step, that is in the initialization of antibody formulation, a random number generator was applied to generate antibodies on a feasible space. In order to have better convergence or superior convergence, we are producing a few new antibodies, and it is continued in each generation. And each antibody will be consisting of number of a particular bus in which DG is to be installed. That is, we are not taking all the buses. We are concerned on, based on this antigen coding, we are concerned on those buses where there is a potential scope for adding DG. Then we are computing affinity. In this step, the affinity between each two antibodies and the affinity between antigen and antibody both were calculated. In antibody generation control, we are improving the performance of immune algorithm. That is, so that it is necessary to control the amount of antibody generation. And then we have genetic operation based on the predetermined mutation rate. This is something related to what we will be doing in the case of your genetic algorithm. So based on the predetermined mutation rate, 2 randomly selected antibodies will be mutated. It is followed by a crossover operation. Hence, there will be a point along the antibody chromosome which would be selected, and this will be operating on each other. Then we have the termination criterion. It is determined by the number of iterations or the number of generation, or it is based on the selection of an antibody which is giving its best performance. So this would be the mathematical modeling. This fitness function is to maximize the voltage stability. So here J represents the number of buses. So N represents the number of network buses. J represents the line. And the voltage range is between 0.95 per unit to 1.05 per unit. And the methodology can be well explained through this. See, we are taking IEEE 34 bus radial distribution system. We are partitioning based on the availability of DGs, and we can go for a different combination based on the available DGs again. So we are partitioning for this case, for this experiment, into 3: partition 1, partition 2, and partition 3. And each partition, along with the immune algorithm, it will be finding its best output. Each will be giving its best. So you have 3 best with the minimum power loss, and they are combined together. Here we are finding which is the best of the best. Right, so the minimum among all local best value will be selected as a global best. So in this portion, we are actually mimicking the genetic algorithm processes. The criteria for partition, how we are actually partitioning the available group. So depending upon the increment or decrement of power loss, which is the major concern here, we move across the network, and each bus will be represented with a label positive or negative. 0 is there, and 0 is having no impact. Like, let me explain. Plus is assigned for power loss increment. Suppose if I am moving from bus 1 to bus 2, say for example, bus 1 will be giving some power loss. when we are moving to other line, the power loss might have been increased, or it might have been decreased with reference to the previous bus. So if there is a power loss increment, then I am assigning a positive label. If not, if it is reduced, then I am assigning a negative label. If they both are same, then I am giving a 0 label. So if loss difference at bus I is greater than at bus I minus 1, then positive sign will be assigned. Otherwise, a negative sign will be assigned. So for our IEEE 34 bus system, this was the partition code generated. 0, because this is the first bus, there is no previous bus. This is the bus at which we are starting with. So accordingly, we do have this. So still we have labeled, but not partitioned. So the bus is partitioned whenever there is a negative sign encountered. Say for example, this is 0, so we have partitioned here, and we do have plus, plus and minus. So after minus, you have to have a partition. So we have plus, plus, minus. So after bus 1, you have 2, 3, 4. Likewise, here you have plus and minus. So you have a sign change here. So here again, you will be having a partition. So accordingly, the partition of buses is tabulated with reference to the assumed or considered IEEE 34 bus system. So the criteria for DG allocation. So only the bus location represented with positive sign are considered for DC allocation. That is, positive sign indicates that there is an increment in the power loss. So we do have we have to compensate for the power loss. So we have to supplement the power with the available DG. So we are allocating DG wherein which we have the positive sign. And bus location with negative sign will not be considered for DG allocation because the power loss is already less at these points. Depending upon the number of buses in each partition, different combination of DG allocation is tried. Say for example, here you have 3 buses, here you have 4, here again you have 4. So depending upon the number of buses at one set, we can go for a different combination of DG allocation. So as far as the size is concerned, we do have some available sizes. Because it is just a simulation study, we had taken only 700 kilowatts and 100 kilowatts, and with reference to MATLAB, we have chosen the best size. With reference to bus number 33, the MATLAB suggested 700 kilowatts of size totally with the available DG combination, and with reference to the number bus number 30, wherein which we are going to insert DG, it suggested to go for 100 kilowatt size. All other results we have carried out with ETAP. So we, in order to show the superiority of the selected algorithm, we have taken the available algorithm, which is ABC algorithm, artificial bee colony algorithm. And as per artificial bee colony algorithm, it is suggested to go for DG insertion, DG placement only at bus number 5 and 28. And before DG placement and after the placement of DG, the voltage levels are shown. See that it is only 99.21, and now with DG insertion, it has moved to 99.81. So see that the difference is only less, but even a minute change in the voltage may affect the stability. So that is why we are, especially in the case of your DG distribution system. So that is why our prime objective is to maintain the stability of the voltage. So at bus number 5 with DG, with the ABC algorithm, it is the voltage profile has been improved and the voltage available is 99.81. Likewise, at bus number 28 with the ABC algorithm, the voltage is boosted to 99.93 from 98.09. But with our proposed algorithm, see that the buses at which the DG has to be fitted itself is different with reference to the algorithm. And see that before and after the DG placement, with the help of the suggested algorithm, is listed in this table. And we have the stabilized voltage after DG placement, which was suggested by the proposed algorithm. Likewise, voltage stability alone is not the objective, but we have considered the power losses also into account. So similarly, with reference to ABC algorithm and immune algorithm, the suggested buses, we have calculated the power losses before and after DG placement, and both algorithms, they have showed the percentage of degrees in power losses much, or I can say that the power loss in the line is considerably reduced by the suggested algorithm. So for all buses, the voltage profile is given. The green color indicates that suggested by ABC, at which we have to insert DG. The bus suggested by ABC is indicated in green color, while the immune algorithm suggestions are given in purple color. See that before placement of DG, it was 99.21 by ABC. And after placement by ABC, it is 99.81. So though it is not suggested by immune algorithm, if we use immune algorithm, the voltage profile has been improved even for this bus. Likewise for bus number 28. And you could see that at 30 and 33, the voltage the voltage level was very low. In fact, the bus at which the voltage was very low is only bus number 33. It was not selected by ABC algorithm, but our proposed algorithm selected that also. And you could see that uniformly the voltage is almost 99.9%. Because it's a simulation, we could able to reach this level, but in practice, it may be lesser than this. But still, we could improve the voltage profile by this algorithm. And the graph for the same is shown here. See that the purple color indicates by our algorithm. So the number of fluctuations, voltage fluctuation is very less in the suggested algorithm. Likewise for power loss, we have gone through the power loss with both ABC and immune algorithms, and the comparison of power loss graphically is projected here. Even from this graph, you could see that the power loss after adding DG, which was suggested by the proposed algorithm, is very less. The power loss is very less by the proposed algorithm. So this result analysis has already been deliberated. So the real power loss before placement, the total real power loss will be 88.5. After DG placement, it is only 38.4. If with the existing algorithm, we can analyze the same, but it is more than what we are suggesting, right? This is again a simulation result. The real figures may vary. And as a conclusion, the DG is placed in the power distribution system using immune algorithm as per our objective. That is, the voltage profile of the system is improved. Also, the real power losses are reduced. And these results are verified using ETAP software. And we had some good references. All were trying to maintain the voltage profile, or they are concerned about the voltage stability of the distribution line, especially when we are adding DGs. Also, the power loss is also a major factor in most of these papers listed. And what I could suggest to the audience is that though it is a pure electrical paper, it is of adding DG, how it is going to create a transient stability problem on the existing distribution grid. Instead of a grid, we will be having a marine power distribution system. There also we are having many kind of DG systems in order to achieve clean energy. So in such case, we can place the DG at appropriate level and appropriate size, which could give better performance for the vessel. That's all is my inference. Thank you very much, sir.
So it's a very good presentation, madam. So
thank you.
Fine. So basically what I see is that it is a kind of heuristic algorithm.
Yes, sir.
Something like a BE colony optimization algorithm. So the one thing I want to know from you is that can it be seen in a kind of smart grid? Can we see this in this way?
Yes, sir. Yes, sir. Yes.
So in such a case, in future ship power systems are looking forward for adopting microgrid concept. In that way, whether microgrids also can be considered as a node for this?
Yes, sir. Definitely, sir.
Irrespective of the capability of the microgrid to deliver, we can program it, right?
Yes, sir.
Okay. So another thing is that what are all the inputs to the, for example, if the hardware system is implemented, So what are the inputs? Only the voltage input is enough, or what and all inputs?
No, sir. No. All the load requirements we have to feed initially. All the load requirements, bus data, all data has to be fed. It's like a software. A software will be doing within few seconds. We will get the result, right? Before designing, we could analyze what would be the case and where it can be actually located. That is what is of major concern. Where we can locate this DG and what size it has to be located.
So mainly during transient disturbances.
Yes, sir. Yes, sir. Yes, sir. And as I said, this algorithm is dynamic in nature. So automatically it would be changing. If the climate is changing, like I mean to say that if the load conditions are changing, automatically it will be changing.
Can it have fault tolerance? For example, if one of the DGs, goes out of the grid actually, or if it encounters a fault, or if a particular DG is not able to deliver it rated capacity. Can it adapt?
Yes, sir. I do not know whether it would be adapting because we have to redefine the algorithm. We have to redefine the objective function because we have not included that. But definitely there would be a scope of some of the DGs available will not be working, or even if they are working, they cannot meet their rated capacity. In such case, there will be again some disturbances that can also be added. We can work it on.
Okay, so in that case, something kind of a hilltop algorithm, what we see for power generations and all. Now this algorithm can allow the power withdrawal from the equipment, and once it sees a dip, for example, if it sees a underperformance, there itself it can take the input and it can optimize a real-time solution. No.
Yes, sir. Yes.
Huh?
Yes, sir.
So that could be more practically possible.
Yes, sir. Yes. With I don't know if it is applicable for a very large system. At least for a small vessel, you said no, sir. The dynamic placing and which are frequently traveling, and there we can adapt to this because the load demand will not be much, no, sir. So where the load demand is not much, then we can experiment such a kind of a system.
Probably all the set input can go to a centralized processor.
Yes.
From there, it can objective functions and all can be checked there, and dispatch can be given to the respective governors and the AVRs, right?
Yes. Yes. Yes, sir. Definitely.
Okay. Fine, madam. Very good. If there are any questions, they can ask.
Sir, give me 2 seconds. Sir is on the way. Give me 2 seconds. Participant, please be on the line.
Yeah, it seems there is no other questions for this particular paper. So first day of this 2-day national level conference, session 2, electrical, electronics, control and automation. Totally 6 papers presented, out of which all 6 are excellent. All presenters have done their work very well. All are innovative. All papers are looking for some further experimental setup or further research. Some of the papers already they are doing some research in their particular domain. So now we are end of this first day sessions. I thank our scientist Dr. Vedachalam from NIOT for his valuable support during his busy schedule. He has given consent to attend this session chair as a session chair for this afternoon session too. Thank you very much, sir. So we expecting the same support in future also. I thank all the participants, all paper presenters for this session too. All are well done. So thank you very much. Over to comparing team. Thank you, sir.
I would like to extend my deepest thanks to our chief guests for their gracious presence and enhancing our spectrum and the paper presenters on day 1 of NCEESS 2020. And we appreciate the management and the attendees for their guidance and sincerity. We will gather again tomorrow with the same gusto. Thank you all for your patience. I wish you all a very good evening.
Thank you very much.
Thank you, the participants, session chairs, delegates.
Thank you all the participants, anchoring team, and especially the session chairs.
We'll meet again tomorrow morning.
Yes, sir. We are meeting tomorrow by 10 a.m.
10 a.m. Yeah. Thank you. Thank you very much.
Thank you very much.
Bye.
Thank you all.
Thank you, ma'am. Thank you, sir.